Start the recording. And let's talk about what we have going on here. So like I said, we've pretty well taken care of some exercises through these points, but I wanted to go over a couple of little review points, see if you've got any questions, things like that. So I'm going to open up. I'll make sure I'm in my folder here. And I'll be over here now. Couple of things, because I'm running on the AutoCAD version with the dark interface instead of IntelliCAD right now. So well, thank you very much. Sorry, my coffee just arrived. I have a hero in the house, a heroine. So, all right. So, so a couple things to point out here. One is I do not, when I'm running AutoCAD, like I am right now on this, I don't have, I had that little layers pull down and I would hit that button and I had that layer, my layers control, which in IntelliCAD brought up that list of layers and I could switch to the different things like the text style and XREF files and all of that. In AutoCAD, I don't have that. I've got actually a similar thing, but individual programs. Like I would go to view and choose layer control, and I would get this box that would pop up where I've got this list of layers, whether or not it's on or off, frozen, whether it plots, whatever color, line type, line weight. Okay, all of that stuff, all of this is the same, but you notice I don't have that list of things here on the left where I can choose those different categories of other things like text styles, blocks, etc., etc. And there's another thing in IntelliCAD with that manager, and I'm gonna run it up here at the same time to show you how that works. And then show you where the equivalent version is. All right, so I'm going to open, let's just use my, say, this example one. And then let's also open let's say this one that we were working on yesterday. Okay, so I have two drawings open in IntelliCAD. Okay, now, if you want to transfer something from one drawing to another in IntelliCAD, all right, I would pop this thing up here and show you that typical process. Let's say I have some layers here like 3D profile, borrow area, floor, boundary pad, roadway pad, that sort of stuff. These are layers. If I look at blocks, I don't have any specific blocks. I do have some layouts. I have no external reference. but it's all done through this in a very interesting manner. And I want you to be aware of this concept, aware of this tool and how it works. I'm going to change this to NCD borrow pit. I'll name that, and I'll put in a couple of interesting little things here. Let's draw some text over here. That's going to be 0.25. We would say maybe start typing some general notes on this is a note two, so yes, three, etc. All right, so we would have, say something like this, perhaps, and maybe things like this that are in your drawing. So if I look at that, that's a block. So I'm going to save this drawing. Then I'm going to go and look at this drawing and see that, I don't have any of that stuff in here at all. But if I had another drawing that had something in it that I wanted to use, whether it's a text style or a layer, any of that kind of stuff, when you run this layer manager or layer control, which on the AutoCAD side is just by itself, okay? So here's my layers, layer states, etc. But notice what happens here. I've got two drawings open. So, and you can see the one that is active is bold-faced. So if I want to say, take some layers, let's say I've got 3D profile, the borrow area, floor, boundary pad and roadway, and pad, for instance. If I wanted those layers and the colors and the line types and whatever else I got, line types are all the same. Any characteristics of these layers, here's one called viewports. Let me also select that with a control click. Oh, shoot, I just messed that up. All right, so that and that, and let's say those. I'm not going to get the bar scale and 3D prof and all that, but I could do it. But I've got these layers selected now from one drawing, and it works from either drawing to the other drawing. Here, I'm gonna turn that video off so it's not so distracting. And then you select those in the one drawing that you have them in, and you drag and drop it into the same category on the other drawing. Like here's class example one that doesn't have those things. So I'm going to just drop those there. Now they've been placed there. You see that area or these layers have now been transferred across. So there's my borrow area floor, there's my pad, there's my viewports. Okay. But that works not only with things like layers and such, but even things like blocks. Here's my bar scale and north arrow I've got in this drawing. I don't have those in this drawing, but I can do that same trick. I'm just going to say, take the north arrow by itself, and I'll drag it onto the same category, which is blocks, over here in this other drawing. And now in this other drawing, even though you don't see it, I have it in the drawing. It's in my list of blocks. You can see it right here. There's that north arrow. I can now from here drag it and drop it into my drawing, into the drawing space if I'm in the same drawing. But you can tell that it's there because if I go to insert, either from a file where I have to browse, or I take it from all the defined blocks, here's that defined block, specify it on the screen. I'm going to put it there and make it, whatever size and whatever direction. Okay, so there it is, just a block by itself. And it also works on even things like layouts. Like there's that ANSI D borrow pit. If I take that and drag and drop that to my layouts, there it is over here in the other drawing. I'll switch back to the other drawing, and I see down here at the bottom, I have these two, and then there's that same layout. Now, obviously, it doesn't show the geometry that is included in model space because it takes things on this page, which include this viewport, which is looking at the model at a certain set of coordinates, and it's doing the same thing right here. It's a viewport looking into the model at the same set of coordinates. There just happens to be nothing at those coordinates. If I did have something, let's just take we'll take that one item. I'm going to transfer this from one drawing to the other, which you would think might be a copy operation, but it's actually has to be done through the clipboard copy. If you just choose copy, that means copy it inside the drawing. So I'm going to take my clipboard and I'm going to copy. I'll go over here and I'll say, right click, clipboard, paste to original coordinates. And I see it's way down here, and it's even got a different color in there. It's in model space. But if I go into my layout here now, make sure my layers, yeah, let's turn that on there. All right, so there now, because in that same coordinate space in the model way down here, which is where this is in its model, now I'm looking right at that same location. You see how that works? So it takes everything that's on this layout, the text notes, the bar scale, that north arrow, that north arrow happens to, and the bar scale, they're actually in paper space. See, I can put them over here. They're just superimposed here. But when I moved it when I also transferred this north arrow here as a block, you can see here, I'll put this down here, into my model. See, there's where that is, but this came over as, you know, something as if it were selected in this layout. Anyway, bottom line is, in IntelliCAD, you transfer all of those different things with this one tool that, you know, a lot of people use this tool and the only thing they ever use it for is to control their layers. But you've got all of that capability. You can take line styles. If you've got a line style in a particular drawing that you want to put in the other drawing, you don't have it defined. Let's say this gas line and something doesn't exist in, although it probably does. I think I may have started with the same drawing template. Yeah, see, that gas line exists in both. But anyway, you can just select set, you know, whatever you want, either all, one, several, either, you know, if you shift click, get on the first one, then shift click the last one, it gets everything between it. If you control click, it gets individual ones. And then you just drag and drop to the other drawing. Okay, so all of that's done within this one control. Now in AutoCAD, because this is such it's such a useful thing to be able to do, particularly if you've got a nice page layout in one drawing that you want to share in the other. And you don't have to take everything. You can transfer it over, and then let's say you know, in this drawing, and here's my other drawing, and I wanted this layout, but I didn't necessarily want, say, this bar scale and that set of general notes, or even one of the of that particular viewport. So I could simply go here, and once I've done that transfer, then I can select these items and delete them. And then you're left, but you still have the page definition, the preview based on the plot style, all of those things are there. So it's such a useful tool to be able to do. Now I'm going to close this off. And I'm going to just minimize that. And then I'm going to go back to the AutoCAD version to show you that similar tool. And it's called Design Center. And so this is to, instead of having that layer control be able to do everything, I now have my layer control out, and it is, unlike that other one, it is a floating palette. I can dock this on the other screen, you know, float it. I just float it here and have it auto collapsible, so it's ready to go with my layers. Now, when if I have another drawing open, just like I did with that one, and I'm going to open, say, this drawing. And I'm going to say freeze off a couple of things, come down there. I'm going to go to this layout. I'll rename this one to say ANSI C, 1 inch equals say 30 feet. All right. Oh, it won't let me do it. 1 inch. Oops. Type it like this. All right. And then I might have something here. I would set this up, modify this to use my drawing to PDF. It's going to be an ANSI full bleed C. Use a plot style like so. Line weights. And we'll set that to be, there it is at 1 to 30. Okay, so all right, so instead of, I'm not gonna, go through and set all the color issues and stuff there, although it should be. Just try this one. Display. All right, so I don't have a viewports layer that displays correctly. I'm not also getting plot style to work. Let's see. Object line weights. There we go. There was what I was looking for. And now I need to put this on a layer like I have over here. And let's just change that to so that's good. So this is on a layer called viewports with a particular color that makes it show up red. All right, so if I want that same layer, even though I have in my other drawing, I have a viewport, see up here. But it's on layer 0. So I want to be able to pull this down and assign it to layer viewports that has that color. I don't have that in here, so I need to get that layer. So instead of having to create that layer in this drawing and try to go back and look at the other one and find out, figure out what color it is, what line style and all that kind of stuff. I like to be able to drag and drop one layer into the other like I did in IntelliCAD. I can't do that with this same tool, but we do have a similar type technology. And it's called Design Center. It's one of the palettes. And I don't have the toolbar up that has those palettes on it. So I'm just going to type it. So this is something you might want to take a note of. You just start typing design and you'll get this little pop-up, but you can spell it out completely, called Design Center. It's also available as AD Center, which is Autodesk Center, or Autodesk Design Center, AutoCAD Design Center, whatever it stands for. In any case, it's going to pop up yet another palette. Okay, that's resizable. You could place that somewhere on your drawing. But here's how this one works. And this works very much like that whole thing does in IntelliCAD. You've got three different sources of the drawings. So I'm going to switch it to like IntelliCAD's. I can even go and open up a drawing from a folder here without having to have it open, is what that folders will let me do. But let's just go to the two open drawings. And just like IntelliCAD, you can open up one to the other. Now, it works a little bit differently in that, let's say I have this sample from T3. See, I'm looking at this layer, and I'll change that to show the layers all listed and spelled out. You see, they're all here, but there's no viewports. Whereas in this one, the one I really would like to have right there, it is viewports. So instead of dragging that onto the category here, so that has no effect, let's just take viewports. We'll take existing final and then buildings. Now, with those selected, instead of dragging it in from this category window and dropping it on the same category, I just drag it and drop it into the drawing space itself. Just going to drag it down here. You don't see anything happening graphically, except down here at the bottom where it says layer added, layers added, duplicate definitions will be ignored. So if you already had one, it won't overwrite it. It will keep what you already have. But now I can see in this drawing, my sample, which is the one I was needing things, there's my buildings, existing, final. And if I look all the way down through, there's my viewports. Okay. So that brought over that the layers I wanted. And again, because this is a palette, you know, I can just keep that floating, and I can now select this, and I'm going to change this to viewports so that now it shows up as red and it doesn't plot, even though it shows up here. I've got, let me make sure I've got my my line. Well, there it is, my line weights, but they're not turned on. Okay, so here's my sheet here, but now it doesn't do, let's see, what did I call it in, there's ANSI 30 scale in the other drawing. Now see that here's my layouts. There's layout 1 in civil demo. There's ANSI 30 scale in this active drawing. So if I want to transfer one of these into the other here now, I need to make sure that I switch to the other drawing. So I'm now in civil demo, the one that doesn't have what I was looking for. I'm going to go to the one go to the one that I want to put something in. I'm going to be on Design Center, I'm going to select that and just drag and drop. It says layout added, duplicate definitions ignored. And so now if I look at this drawing, I have not only the this layout one, but I also have this ANSI, which is a C-sized thing. Now you may have to do some adjustment. Go to your page setup, modify that. It's going to use that. Oh, I did switch it to a D size, so it's there. The only problem that I've got with this one is that this is way too large. And so I would simply, you know, resize my viewports, and you know, but it would get like all the, you know, north arrows and bar scales and notes and anything that you have from one into the other. So we drag those through this thing called Design Center. Same thing with, let's say I'm in civil demo and I'm going to look at my blocks. I'm going to get the two blocks there. If I look at these blocks, notice it's got quite a few different blocks. There's a tree, a sign, a light pole, utility pole. So I could take these particular items and then I'm going to put them into my receiving drawing, which is this civil demo. I don't have those blocks in there. So I'll go to Design Center. They're selected. I'm just going to drag them and drop them right here. Okay, so it is now transferred those block definitions. I could then insert in my current drawing. And here's a list of the blocks. Let's see, my current, right. Well, let me see, they've changed this.
1 sec. Draw the line by Current Affairs now playing.
Wow. Siri listens too closely. All right, so I've got these. Oh, come on. Hang on. For heaven's sake, where is my... Sorry. Oh, sorry about that. All right. So now, while here, let's see, I'm in sample 3D. If I drag, so insert a block for the blocks palette. Okay, so I'm going to put this. So if I right click, can't copy, just create a tool palette. All right, so now I've created, I right clicked, I could have said insert block, but I right clicked and said create a tool palette. Not sure exactly. Now that that tool palette is up over here, I get off of this palette and go to the drawing that did not have those. Here's that tool palette. Now I can drag and drop those blocks from there anytime I want to use those. Okay. Go ahead and turn that off. So they're the blocks from the one drawing that I don't have to try to go out and find on the disk, or even sometimes you'll get a drawing from another colleague or a client that has a block defined in it, but you don't have that drawing to use as a block. So that's one way you can sort of harvest those resources out of that other drawing. So anyway, all of that aside, what I wanted to illustrate here was in IntelliCAD, this is a pretty significant difference. You've got let me go back to the IntelliCAD version. Sorry about that. In IntelliCAD, you have this very powerful tool, all done through this layer manager is what people call it. It's really the Explorer, and layers are just one aspect of it. Okay, you can take line types, text styles, anything there. The only thing that if you want to transfer from one drawing to another, you have to have the other drawing or drawings, it can be more than two, open, and you select what you want from these different categories. You drag and drop onto the same named category in the other drawings, and it transfers those or copies those over to the other drawing. So that's all very powerful, all contained in one tool. That equivalent tool for you AutoCAD folks is, put that down here, is this thing called Design Center. And you can either just type the command, or you can, it's one of the palettes. And I don't have the toolbar up in my layout that has shows all of the palettes, but you could just put that up. I don't think it's under view. See, maybe a window. Yeah. Not really, but anyway, it's a very similar functionality, but this is a floatable palette, dockable, just like the properties box is over here. And then you can take those, not only could you do it the same way, having both drawings open, but you've got these other options. You could even just go to, say, another drawing. Let's look at, some from here's one. I'm just in the folders. Now this drawing is not even open, but it's got these different. So here's some different blocks, different trees and such, or different layouts. And I'll get these so you can see the names of them. Line types. Right, there's one, OHP C102. I'm sure I don't have that in my other drawing. So I go to my drawing that I want to receive that and just drag. So there's that one and sanitary. So I just drag those and drop them in to this drawing. And then I can look at my layers and look for that. So there's that OHP and there's that sanitary. Okay. So everything works the same as the other one, except you don't drag and drop category to category. You take it category to drawing, except for blocks. You have to do blocks. And this is only with the new version of AutoCAD, I think, with at least 2023. It might also be 2022, but blocks are now done through their own palette. That's why in Design Center, when you're looking at blocks, you select the ones that you want, and you would right click and choose to create a tool palette, or you could, if you said insert a block, it's not, yeah, you would have to create it as a palette to get those things to show up as a tool palette. Then you can switch to any other open drawing See, there's those. You can see that tool palette stays over there on the side. And I can then just drag and drop those from the tool palette into my drawing. Okay. I'll close that off and not need it. So there's your equivalent tool, Design Center. And it could be something that you find you use quite a lot if you've got some drawings that have already been created and you want to start transferring some of that intellectual property. That's the fastest way to do it, other than wholesale. Open the drawing and do a save as, but then you've got to go, maybe you've got all this stuff you created in one. You don't want to have to recreate it in the new save as copy. So you can do this after you've done some significant work here. You can now go to another drawing and start to take some of those resources and bring them across. Okay. So that's just a little bit of a real kind of deep look at a tool that I hope you'll find useful with some of this stuff. Now, in terms of what we looked at yesterday, just as a real quick review on a couple of things, we talked about, let's go back up here. We talked about a couple of things. Talked about how things are organized, where they are directory wise. We talked about sort of a decision tree to help you figure out what commands you want to use. So for instance, if you are, let's see here. By the way, let me ask you a question. You guys can clear that up. You see here in the IntelliCAD version that I'm showing you on the screen, my toolbars have this sort of silver background. They're light colored. Whereas in my AutoCAD version, they're dark. Does this show up okay across Zoom on what you're looking at? Or would you rather, see if I can find it. Yeah, would you rather it look like sort of similar? Okay, I'm going to need to, I've got a phone call coming in. I need to take a quick call. So I'm going to mute you guys. I'll be right back. Or mute. Okay, everybody still with me? I apologize for that. I've got a little drama unfolding. My son sideswiped a car on the street the other day when he was he was picking his son up from daycare, and his son tried to crawl over the back seat and he got turned. Anyway, it's all a mess and trying to get that straightened out, sort of helping him out on that kind of stuff. All right, so we're back to this. So anyway, here is the AutoCAD in light view. Does anybody have a preference as to whether it's light or dark? I don't particularly care one way or the other. I think the icons might show up better in the light view.
They show up a little better. I mean, either one seemed pretty good though.
I just don't want you two AutoCAD users, you and Chimuzi. I don't want this to be I don't want the light interface to throw you off a little if you're using dark. If you're using dark, we'll be glad to do it. So I'll leave it here light if you don't mind, because that way the icons I think are going to show up a little better. All right. So, and then we've got both versions up and running. We'll use that to highlight any differences. Let me get this. I wish I could put that somewhere out of the way. Let's see if that'll, all right. So what we talked about in our, we talked about the directory structure and the menus and how those work and how you've got general menus versus the modular menus, on the general menus being the file through points. And then the modular menus starting after the points menu, where you have things like this and this for each module. And then we started to talk a little bit about sort of a decision tree as to how to figure out where to start looking for commands and tools. Because we start out with, hey, we've got two possible states of things in our drawing. Either things exist or things do not exist. If they do not exist and we want them to exist in our drawing, then we have to create it somehow. And some of our tools that we're going to look at to create with are under, say, a draw menu. Okay, that's in our general menus, and we can draw things like 2D polys, 3D polys, hatches, etc., all kinds of different things. But there's also commands over in the modular menus, things like, if I've got a polyline, I want to create a center line. We use that a couple times, or I can station my center line. I can go to my annotation, do that auto annotation where I can calculate and display the labeling. That's what the annotation means. It's going to label geometry in my drawing. Or I could go to the surface menu, triangulate and contour. So that's going to read some data. We're going to fill a bunch of stuff out. And we're going to get into that tool here today, how we gather up our data and create a terrain model and generate contours for that. So these are all things here, and these things that are beyond the points menu, these to the left of the points menus are the general things. Draw, where you just go out and manually draw and create these things, again with some very specialized tools. But beyond the points menus, you're into the modular commands, and these have things that, more so than the general commands, these commands are going to work with these external files. Like, remember, we had that centerline file. We said polyline to a centerline file. So it creates a file and stores it on the disk that we can use, whether it's drawn in here or not. And when we're working with things like those files on all of these different manipulation menus in the modular side, you've usually got an editor, like you can edit a center line and you can draw the center line. So you get some draw tools, you got some editing tools, and then you've got some sort of specialized calculate tools, often a reporting tool. So there's, say, with center lines, if you look under surface, the surface menu, you can, even though you may have created the surface file in another DWG file. It doesn't have to have been the same file, but I can say, draw a surface. I can draw contours from a TIN file, that triangulated irregular network. So it goes out and has, and I've got some editing tools in here, although there's a better way to edit surface data than trying to edit the file. We actually edit the data and then recreate the file. That's a better approach. But we have those editing things. We have draw things. We have some report things. We have some label things like, you know, moving the contour label along a contour line. You know, as long as it was created with, and that wasn't, that's actually a line. It's chopped a hole in here. It has to be created in a different fashion. We'll get to those specialized tools. But so bottom line is, if it's just to draw some geometry, to create some things, look here first. If it's to generate one of these, you know, civil or land development type of things, you most likely would be under these other areas here, you know, centerline editor, draw a centerline file, station it. There's your labeling, there's your drawing. So you can go out and read the external file. Surface, all the different things that correspond to that. Similarly, in civil, you have, there's your triangulated contour, same command. You've got these volumes, okay, by triangulation, some stockpile volumes, pads, ponds, different things that you can typically do with that. But notice on centerline, there's your centerline editor, there's your draw centerline, there's your station centerline. You've also got profiles. Here's your profile editor, here's your draw profile, here's your profile reporting. You've got cross sections, you know, your section alignment editor. You've got a means of creating sections from different things. You can draw your section file. You can get a section report or label, you know, different portions of those cross sections. Okay, so these specialized menus tend to be more advanced and deal with things that create those external files, things like center lines, profiles, pipe networks, triangulated irregular networks, or terrain models, cross sections. Okay, all of those different things that can live outside of the DWG file and be used in other drawings. Okay, Josh, yes.
I don't have that, the sections,
The sections and profiles, because I switched
yeah.
to the civil module,
Okay,
and I was
okay,
previously in survey. Okay,
okay, all right.
yeah, good question. So yeah, I did that with this toolbar here real quickly. You may not have caught me doing that. So
Okay,
So anyway, but that's the thought process that we wanted to go through, is that we ask ourselves, you know, is this something that I need? If it's not there, how do I get it? Okay. And I can either draw it, and if I knew where, let's say I needed to draw this building, and if I know where, you know, this building corner is and this building corner is, I could just go straight and draw a polyline, and I can type in the coordinates as to where that's going to go, or a distance and such. But you know, that's going to be kind of tough to do for all of these houses if I'm just trying to guess where those things are. So I would go out and typically survey everything I'm trying to create, these existing conditions, and then I would bring that data back into my drawing, and now I've got to create it. But what do I do when I go out and survey? I get a list of points. And when I have those points, let's see what was, yeah, that's what I thought. Use the empty file. Anyway, so if I have those points, let me set to a different coordinate file. We'll just use this one. So when I have those points and they're out here in this other file, just separately out here, then how do I turn that into, say, that house outline or the driveway or what have you? And that would be, we're gonna, again, that house outline's a polyline. We're just gonna draw a 2D polyline. And I'm going to notice that one of my prompts says pick a point or point numbers. And so maybe my point number was 15 through 21. Now that's going to be, off here to the other space because all of those other surveyed points were out here. I don't notice when I drew that 15 through 21, I did not even have to have the points drawn in my drawing because it's reading that outside CRD file to create this geometry. I'll verify that just by drawing this. I'll draw them all and you'll see where they all come in like we were working with yesterday, but it drew from 15, 16, 17, 18, 19, 20, 21. Okay, so those are a couple of things that we can be aware of that we have gone over. I want you to realize, get a sense of how you generate this information. You're going to create some points, perhaps. These are Carlson points. And you can double click a point and you can edit things like symbols. You can change descriptions. You can type new coordinate values if you want. But you're going to also possibly have the opportunity or the need to say, move a point now. This was working yesterday when I put this to bed. Let's see. All of my linking, that's what helps that to all right, so there's something else. What I just discovered there was even in the AutoCAD version, I drew this line the first time back when I was down here. I drew it when the points were not showing in my drawing. I said 15 to 21. It read the coordinate file and put the drawing element in based on those point numbers. That worked. I then drew the points. So the points are now in the drawing. And I tried to move the point to get the line work to follow. And it did not. And this is not actually an error. This is actually behaving that way because it's these points that this line was created from. So when these points get moved, the line's going to react to it. But it's the things in the drawing that control that reactivity, not the same things in the CRD file, in the coordinate file. Okay, it's a subtle distinction, but they have to have been shown in the drawing before the line will become reactive to it. The line will recognize the points from the CRD file and will create itself But that's not the same as saying that that line was created from points in the drawing. And that's the only way you get that reactivity. It has to be done inside the drawing to get that to work. All right. So working with points, we said point style. We've got some defaults up here where you can change. Let's see, I'm gonna set a different, default kind of behavior for my points. If I draw all, so it's going to erase those and redraw them. Now, it's the question I've got. Yes, okay. So notice what happened is I redrew my points, which erased the previous points and drew them again. And so now when I move those points, it's not making the line reactive because the line was drawn with a different set of points in the drawing. All right, so that's all behaving like it's supposed to. All right. Now, one thing that you need to be aware of on the AutoCAD version, the IntelliCAD version is already handled that way, the way it selects certain entities, but I'm gonna point that distinction out to you here in a minute as well. So one thing I do want to do first is I'm going to go to text, I draw text, and see this PTX. I'm going to change the font that is being used. This displays a little cleaner. To it. There we go. Now, when we are selecting a point, when we draw a point, I'm going to go up here and work with this point here where it says it has a description. These are all attributes. So I've got three different things. If I select this, I've got a group, and that group is composed of two blocks, and the block being the symbol, which is not necessarily required, but it's there because of my defaults. That's one block. That's called a graphic block. And I've got another block over here called an attribute block, which is it's a block, and it holds placeholders, which include a point number, an elevation, and a description. But there's also, as you see, a point that is a CAD point entity. Now you can have points in your drawing and they not be AutoCAD points. But an AutoCAD point will include that point. Okay, but not all points are AutoCAD points. So now, one of the things that I did in the IntelliCAD version yesterday that we looked at, and I'm going to see, we've got some points. We'll use the same coordinate file. And it's like way far away over there. That's fine. I'm going to go down here. So now one of the things that we did in the IntelliCAD version is I would select that point, and if you move the grip to a new location, it's going to move the whole point and prompt you to update the CRD file or not. Okay. If I then choose individual, change this default back. And let's use a different point symbol. I'll use that one there. All right, so if I use, if I select it, I get, notice how many grips I get. 3 grips here, 1 grip here. And if I just pick any part of it, and then if I move, if I go into the grip and move that, it's going to move the entire point. If I grab one of these other grips, then I'm just rearranging where the labels go. I'm not moving the point, okay? So I'm doing that, and I can also do that from my points menu. I can move point attributes individually. I can move point attributes with a leader. So I'm going to say move there, and there's your move with the leader, all of that kind of stuff. Move that with the leader again. I'll just restore it. Okay, now, but when you're in the AutoCAD version, this one I want to point out to you, you don't by default have that. You have a different behavior. And let me see, it's typically, there's 2 places where it's controlled. And I think the first time it's set up, this is not turned on, that group point entities. That's what puts those 2 blocks and the point all together. So when you select any one of them, you get everything. That's the better way to have it. So this is typically unchecked by default. And there's another setting in our selection that is set by AutoCAD by default. And so that would typically be is if I select this now, notice I only get 1 grip for the whole thing. So if I see that 1 grip, now see, that's still a group. I still have the 2 blocks. I still have the point, but I can't move those attributes around. If I grab that grip and move it, it takes the whole thing. So that works correctly there, but I want to be able to grab those attributes individually, but I can't because of the way my particular setting is done. So here's where you want to make sure, you AutoCAD users, go to the settings menu, Carlson configure, general settings, and make sure, first of all, that this group point entities is checked on. Okay. But then you want to right click some empty space in the drawing and choose options. Now, across the top, you got a series of tabs. Go to the selection tab over on the right. And it's on the right-hand half under here for the grips. You set the grip size, but we want to turn on this box here at the top that says show grips. And then you want to turn on to make sure that you uncheck this box right here that says show single grip on groups. Okay. So that's what created that. When I selected that point, it only gave me that 1 grip. And it's a matter of convenience because you can make a group out of anything and it just gives you 1 point of reference to control it from. But if you have that on, it also prevents you from doing these individual readjustments. Okay. So if you needed to move these into a different arrangement, you can do that. Okay. So that's just a setting to be aware of and a difference in AutoCAD and in IntelliCAD. Okay, now we are going to, let's see, it's now 10:30, so we'll go ahead and take a little break from mid-morning. I know we had the phone call break, but probably didn't give you enough time to get your stuff done. So we're going to take our 15-minute mid-morning break, and we'll come back at 1/4 till the hour. First of all, does anybody have any question on anything? Everybody good? All right. So we'll come back to there, and then we're going to start to dive into some of these a little deeper with some more complex data, so you can see some of these other tools. And as we go through those processes, we'll go back and be reusing some of these tools that we learned yesterday as a little bit of a review. Okay. So I'll see you everybody back at 1:45. Okay, folks, I'm back. And everybody here, Josh is back. Okay, good. Okay, it looks like we're all back in the game. All right. So we learned a couple of tools and some things about points. I'm going to, in the interest of a bit of time here, we've gone through these point exercises, but there's a section here using point groups, and I'm going to leave this one to your own independent study after class. Sometimes it's really just an extension of using points. It's a means of categorizing your points into different groups so that you can refer to a particular range of points by a group name instead of by a series of numbers. Certainly nothing critical. It's really more more useful and more used by surveyors who have like hundreds and thousands of these different points to manipulate. So, and like I said, you could be potentially doing some of this work without ever using any points. You know, I do that sometimes quite a bit. And there's a nice little exercise that uses these point groups. It's in your book here in order. Like I said, the data files that you need to go through these are part of that download that you've created. But one of them is, if you see here in the document, you recognize the houses and the driveways and the little individual lots, but you see these little round circles. Those are actually Carlson points. They're not just circles placed on all the property corners. They're actually all the points drawn, but the point number, description, and elevation have all been placed on frozen layers, so you don't see it. But if you were to go and double click that little circle, you would actually get a the point editor would pop up. So but it was a real quick way that we were able to create those and put them into a group. For instance, like this group created called property corners. Okay, so that's sort of a nice little practical application that's part of the exercise. So let's move ahead into the real meat of what we're trying to learn here with Carlson software and what we're going to be using and exploring. And that is terrain modeling. And first of all, let me sort of ask the class, how familiar are each of you, or any of you, or all of you, if or none of you, with the concept of doing terrain modeling as to what it's involved? Let me go ahead and just have you all, you can all, throw in some discussion, whatever you'd like. And what I'm talking about is this: we model terrain, we model a surface, okay, by collecting usually points along that surface and putting them together into a sort of a blanket, where we are essentially guessing in between the points that we measure, saying that, well, okay, there's no abrupt changes. It changes in a consistent manner or a linear manner between this point and that point. Okay, and then we put all those points together, we make a little blanket out of it, and that's now our surface. Okay, and that can be anything. It can be the existing ground, it can be design ground later, it can be a surface that is composed of the population density distribution throughout a particular span of years. You know, it's any kind of data that can be actually turned into a surface. But in our case, the way we're doing our work, we're talking about the ground. Okay, we're building surfaces based on the ground. And in our survey side of the field, we're collecting existing stuff and trying to model it the most accurately. And in our design side of the field, we are trying to communicate our desire for what we are going to do and end up with as a final condition. Okay, simple. That's, you know, the basic, simple nature of it. So in your book, we talk about this surfaces and contours, starting on page 18. And there's a little bit of background that we go through here in discussion here. I'm not going to just read all that thing to you, but it's pretty important that you realize because a lot of people, especially older practitioners that have come at this prior to computers being in common use, that would be people like me, where you have, you know, our whole mindset and feeling about topo, as you would call it, as a shortened term, or topography, is, oh, those are contours. Well, contours, as it shows you right here, that contours are just one way to show you what the three-dimensional ground looks like. Okay, there's all kinds of other ways that you can do it, and it is an output from the model. Okay, so I can have a model, and if my model is accurate and correct, I can draw 1 foot contours from it. I can draw 5 foot contours from it. I can draw 3.6275 foot contour intervals from that surface. The surface is the part that doesn't change. Okay, so that model is what we're after. The contours are just a temporary snapshot of that model. So read this discussion when you have a little bit additional time. You want to sort of really sink this part in. Now, what is your knowledge level, everyone? Let's say anything from you know, none to some to, oh yeah, I understand it pretty well. But we talk about this process called triangulation. Everybody, is anybody or is everybody familiar with triangulation as a process?
I got zero knowledge.
Okay.
Yeah, I'm not either. I don't have any knowledge.
Okay, Chimizi, you've got your thumbs up as you've got some basics already understood.
Yes, I use a lot of triangulations in the work I do.
Okay, so and you understand what that process is involved with. Okay, all right. So I think what we need to do though is to talk about real briefly, especially for the folks with zero background on it, is what is this thing that we call triangulation, and how does it work? What's going on with the computer? And I'm going to do that through a series of little pictures and things like that. If you consider a terrain model, you've heard me use the term, you've seen the extension on a file called a TIN, a TIN, and that stands for triangulated irregular network, because what it is composed of is let me show you a picture of one right up here. It is a network of irregularly spaced triangles, and that forms, and you put all those triangles together edge to edge, and that forms that blanket, that complete surface. And why triangles? Why not squares? Why not, you know, weird looking things or rectangles? And it's because triangles are the minimum shape. It takes a minimum of 3 points to form a portion of a plane. And you put all of those portions of planes together, edge to edge, to model the surface. The more closely you put those things together, the smaller the triangles, the more triangles you have, the more change you can represent and the finer you can make your model. One of the problems is, though, that if you get too many, you get things too cumbersome. That's way more than what you need, and you sometimes can overload equipment that you don't need to. We're not going to be able to practically use those things. So what we wind up doing is let me go back now to where we left the discussion right here. So we have to let the computer gather up all of those points and decide to start drawing triangles, or starting to create a little piece of a plane using any 3 points. Now, if you look at this figure right here, these are 4 points with elevations, and they could be done the way, sorry, this over here. That could be, they're surveyed with their elevations, and that's all very valid. One quick second, let me get back to this thing. It says, okay, all right. So these 4 points could be what with the surveyors brought in. They could be very valid. But if I'm going to create little triangular patches of this ground based on those 4 points, what do I have? If I look at this, I've got 2 points here at 110 feet elevation, and then I've got a point off and to the left of 100-foot elevation. I've got a point off and to the right at 100 feet elevation. So that falls off left and right. So this is a ridge line, or it's sort of like sitting on a saddle. It's high across the middle, falls across the left, because remember, we're going from everything we're going from everything that we consider between points that we observe, we have to assume changes in a constant linear fashion. So this is one potential interpretation of those 4 points, correct? And so if we look at the other potential, keep in mind this line that goes across here, we're saying 110 to 110 doesn't change, it's level across there, but it falls off to 100. It goes from 110 down to 100, back up to 110, down to 100, back up to 110. But the other potential is that it could look like this. These are those same points, and it could be that we go from 100 to 100. See, before we had that ridge line that went southwest to northeast. Now we actually have a valley that goes from northwest to southeast, because it goes from, if we start down here at 100-foot elevation, we could walk that valley line and come down here and stay at 100 feet elevation. But if we go up to the left, we climb to 110. If we come over to the right, we climb to 110. And I say to the right, meaning I'm walking in this direction. I'm walking toward the southeast. So left to 110, right to 110, stay on the valley floor at 100. So those 2 interpretations are equally valid, but considering those 4 points. So we have to know what the real condition is. We have to know, based on the fact that we were out there surveying this information, or we've seen photogrammetric data sets or what have you. We have to know whether this condition prevailed, the ridge condition, or whether the valley condition prevailed. And we gather that information because we have more than just 4 points. We see how that feature actually behaves. But we can control that because the computer doesn't know. It's free to do this interpretation to form the triangles that make that into a ridge, just as much as it's free to form these into a triangle, sort of. And I put that caveat in there because there's a thing behind the algorithm that's going on. It's called Delaunay's criterion that is actually used to form the triangles throughout your data set. It's all very mathematical and has to do with statistical and regression analysis as to how these triangles are divided and subdivided, et cetera, et cetera. We don't need to worry about that in terms of understanding the mathematical stuff there, other than to let you know that, yes, there is some math behind it that governs that behavior, but it's not a guarantee as to which way these things form. And sometimes they form based on the order of the points, the order in which the points are read. Sometimes they're formed based on Delaunay's criteria, because it will draw the smallest enclosing triangle it can find around given points in the data set. So there is some control behind it, but we don't have any conscious control over it. To us, it appears as if the computer could equally call that a ridge line or a valley, and we have to control how that happens. And we do that through a thing called a break line. Okay, so we have to create break lines, or once the computer creates a break line by forming the triangles the way it's going to form it, then that serves as a break line as well. And what that means, and the reason it's called a break line, if you look at this original figure with the ridge line, a break line is a line along which the grade breaks. That's the reason it gets its name. I like to think of an easier way to remember it. And here's this, about over here, what this is called. This is the break line. So I like to think of it as, instead of trying to recall that that's where the grade breaks, just think of it as an edge. If it's an edge out there on the ground, then that can be turned into a break line. So if this were, walking the top of a ridge and it fell off to the valleys either side, then that's basically an edge up there across that crest line of that ridge. Okay, so because I'm coming up one side, hitting the edge and going down the other side. The mathematical function that break lines provide is that once they are formed, they prevent the one side, the data on one side, from looking across it to data on the other side. Sort of like building a wall over here to keep these points from seeing each other. Now, when I say seeing the points from seeing each other, this is how the process of triangulation works. The computer goes through and looks at every single point, every single vertex that might be drawn in a polyline, in a 3D polyline. Anything that has elevation, like I said, it doesn't have to be a Carlson point. A lot of times it is, but a lot of times it's also done by three-dimensional line work. And it goes and it sits on every single point in the selected items, in the selected data set. And it sits on that point and it starts to look around itself in a circle. And it tries to evaluate whether, okay, if I can see from where I'm standing on this point, any other points that I can see, I'm going to draw a line over to that point and assume that this surface changes constantly or consistently from where I'm standing to the point that I'm looking at. I assume a linear change in grade, if any. So it starts drawing in little triangle edges. Once those triangle edges are drawn, no other lines can cross them. Okay, so if I have my computer looking at these 4 points and it sits down here on this southwest point at 110, and it starts to look around itself, pretend these lines are not here, it can see all 4 points. So if it looks up and it sees that 100, it goes, oh, okay, hey, I'm going to draw a line up there, and that's fine. And I'm going to keep looking around. I'm going to look over here. Over here's a point called 110. All right, so I'm going to draw that line. I'm going to look over here to the right, and there's a point called 100. I'll draw that line. Okay, those are fine. I've created a couple of lines here between my points. Now, what has happened is, like I said, it sits on every single point in the data set and does that process. So once this line, the 110 to 110 line, is created, it moves up here to this other point, and it starts to look around itself in a circle. It finds points over here, 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 and here. And it goes, okay, well, I look at this, I see from 100 to this 110, excuse me, I can see that point. So I'm going to draw that line. And I can see between where I'm standing at this northwest corner down to the southwest corner to the 110. I can see that line, although it's already been created from the other direction. But because this line is in the way, I'm not able to see across it to see this 100. So this line that got generated was what prevented this valley point of 100 from looking across and seeing this other valley point to 100. And so its behavior is, instead of walking a constant line from 100, 100, 100, 100, 100, 100, 100, it goes 100, 105, 110, back down to 105, back down to 100. So that's a very different description of the ground in there. Okay. So if, however, we have a valley and we don't have this ridge going across the 110, the way we keep the computer, the way we prevent it from modeling that as a ridge is, before we do the triangulation, we have to create this line. We have to draw that in there as a three-dimensional line. So once the line is there, it's not going to be able to sit on one and look across at the other. It works as that break line. So that's the basics of that. And the real simple rule is right here: when and where to use break lines. And sometimes you don't need them because your points are clustered correctly and it will model correctly anyway, but sometimes you have problems, and you'll see that in our exercises. But the rule is, because they're really not any, there's really nothing more to them than them being edges. And so if it is an edge on the ground, we need to make it an edge in our data set. Okay. So here's a good example through these illustrations here. If I've surveyed points A and B out here on the edge of the asphalt on the lip of the gutter, this is a curb structure, of course. A and B is on the lip of the gutter. C and D is on the actual flow line. E and F are up here on the top of the gutter, or top of the curb rather. C and D are on the face. E and F are up here on the top, and then G and H are on the back of the curb. All right, all very valid points to have surveyed, okay, in our data set. So here is a here is potentially what can happen. If I go to point A and I sit on point A and I start looking all around myself to figure out where I can start creating triangles, I being the computer, I look up here and I see this point B. Okay, well, that's perfectly fine, because it does indeed change from A's elevation up to B's elevation, or down to B's elevation along that line with no particular interruption in between. So that's a valid edge. If I look at point A, I'm sitting here on the lip of the gutter, and I look over here and I see point C. Well, you can tell that that's going to be a line that walks the face of that gutter, even though it's sloped, but that's still very valid. However, A can also look up here and see point E. And it said, the assumption is mathematically now that the surface is going to change from point A up here to point E linearly, and it does not. It needs to go down to the face of the curb and then up, because right now I've just assumed that I've got a surface that, you know, as if somebody just filled in a shovel full of concrete and they're in my curb, which is not going to be very pleasing. All right, so I've already see that I've got a problem right there. I could technically also be able to see this point G, that I could say I could go from A all the way up here to G, but because this E to C, which is a valid one, is already created, point A can't see point G, can't see point F, because they're already got barriers in front of them. So in this particular possible interpretation, I've got some valid triangles like A, B, C, A. And then these other triangles are all invalid, because I really should have, instead of this one here, G looking at C, cuts right through the curb, I should have E to G to F and then back to E. And you can see how that triangle all lies on that top plane of that curb. I should also likewise have E to F to C back to E, and that triangle lies on that vertical face of the curb. So those ones would be valid. Okay, I can also have some, you know, F to C to D back to F, but not F to B. That part's invalid. All right, so how to have prevented that would be, like I said, we come in there and pre-draw, not the triangles. Okay, forget the triangles for a minute, but we're going to draw the edges. So if we go ahead and draw a line through A and B and extend it as far as the structure goes, we draw a line between C and D, extend that all the way down the length of the structure, and then E and F, and we extend that throughout the length of the structure, throughout whatever our first point and last points are. And the same thing for the back of the curve, G and H, and then we've got that drawn in the drawing in 3 dimensions based on those surveyed points. Now, because you can see right here, I've got this segment E to F is drawn. C, whenever the computer gets around to sitting on point C, it's not able to quote to see, end quote, point G. So it can never form that triangle edge. It's going to only look around and connect to what it can see, what is not got a barrier between it. And so it looks around and it can, oh, there's point F, I can see it. And so it creates that from this face of curb, it climbs up this vertical side or near vertical side to point F, same thing up to point E, but it cannot see point G, okay? And here now C to F to D back to C, C to B to D back to C. So all of these triangles are now valid because I have gone in ahead of time and drawn in the edges, the boundaries of the structure. These diagonal looking lines will create themselves, but I need to have those edges to keep invalid triangles from happening. Okay. And again, way you do that is with this little rule here. If it's an edge on the ground, make it an edge in the data. Okay, so everything that I create, if I shoot a bunch of EPs for edge of pavement, I want to connect all of those edges of pavement to prevent the crown points from seeing the ditch points and deciding that it's a straight shot down to the ditch, and it's not, it goes to the edge first. Okay. So again, as you go through this a little bit more depth, we're going to use these break lines as barriers. Right here we talk about using break lines as barriers to prevent a point from seeing points on the other side. That is going to control our triangulation process. Here's some different sources that we can always use a list of points in XYZ format. Excuse me, but most of all, we're going to get data in the form of either points like spot elevations or drawn three-dimensional line work. And so that in our plan view is going to look something like, you know, this bit here on the left. But if we were to turn that up and look at it in a perspective view, it's going to look like this when we have it drawn correctly. We see we've got all of these little lines as edges, and this is data that was compiled photogrammetrically. So this was done through a, you know, what's called a stereo plotter. And you can see if you follow this line right here, you see that's the little crest of a little ridge, okay? These lines of different colors, you can see the edges of the roadway. And you can see this line up here is, you know, the top of the cut, and it drops down to the road. But sometimes when you look at your data, you're looking at it in plan view. So you're looking at it like this over here on the left, and there's no information there that tells you whether it has the right elevation or not. And if you spin it up and look at it in 3D, you're going to be able to verify visually, at least, whether something is at the proper elevations. We look at this picture on the left, and that looks apparently good. But a lot of times, you're seeing we've got road edges and a stream center line. But a lot of times you'll see mapping companies deliver something like this, where you've got the stuff up here that is at the right elevation, but then all this other stuff down below, which would be what you're looking at here, the road edges and driveway edges, they didn't put at elevation. They're down here still at 0 elevation. And those things need to be up at elevations to be able to form break lines. Okay, so everything has to be done at its proper elevation. Okay, so, and we'll see some tools on how to do all that. Now, one other potential issue is right here, exterior triangles around the outside of your known data. And they form because, like I said, the computer goes to every single point, every single polyline, everything that has elevation, and it looks around itself in a circle. So if I'm, you know, say over here at this point here on the left, and I start looking around, you can see the triangles that it did create. The computer put this triangle edge in, which kept this point from looking across and seeing that point, and that's fine. Okay, and those two may be very close to the same elevation, the same planar edge anyway. So that's all, these are all valid. Anyways, it goes around, it goes around, it goes around. But if you look out here, I'm out here at the ends of this little driveway edge. And it's starting to look around, it sees this point, it sees this point, it sees this point. Those are all good. But it also can look way down here and see this point. It can look way over here and see this point. And in fact, you know, this point can look way down here and see this point. So we need to not only consider making all those edges on the inside between our data sets, like edges of roads and ditch lines and such, we also need to put an edge all the way around the outermost limits of our data so that the outside data can't look across and see points over here. Because what we're saying, if we do allow this, is we're saying, okay, the ground changes from this edge here up all the way up across this open space to this edge linearly as a consistent change. It goes from here to here, and we don't know that. There might be a giant hole in the ground here. It might be, you know, a big hilltop. We just don't know what's there. So those are invalid triangles. Now there's ways we can get around it. We can let them form and just ignore them because we're not usually working in that part of the model. We're usually over here in the interior somewhere. Or we can create the contours and then go through, and with an editing process, we can select, select and delete those contours. That's something a lot of people actually do. They'll go ahead and generate the contours and then delete them, or the triangles and delete them. But the simpler solution in most software, no matter who makes it now, does it this way. The simpler solution is to draw a boundary around it. And that will act as a break line, just like we do on the interior side, but it also just creates an edge that it chops off the triangle formation along that edge. So that will be our preferred method. Those will be the tools that we're going to use, and then that will keep those from happening. All right. So that's really where we're looking, and we're going to load up some real data, and it's actually photogrammetric data. And let's see, Bill, I think you're the only one in the group that might be or most likely familiar with this area, but this data that we're going to look at is actually real, from the real world. And it is, if you're familiar at all with coming east on the Pennsylvania Turnpike, a town called Breezewood, where I-70 and I-76 intersect.
Yep.
All right, so this is part of that area down there. This is, after you turn it, well, anyway, we'll talk about it. This is where you come off of 70. If you're coming from Maryland, from the Southwest, West Virginia, Maryland, you come up here, and I-70 is you take the exit, and then you can come around down here, and over here's the light, and then you can come up here and go to the east, and then you get back on the turnpike ramp back over here. So that's where
I know that well. Okay.
yeah. So anyway, that's where it is, and I'll show you a couple of cool things when we get into this data set. So we're going to work with the rest of our stuff here using that particular data. We're going to talk about how, what do we do to add break lines. And we'll go through some of this. I'm just going to show you these pictures and talk about what we're going to do, and then we're going to dive into that. But one of the things, a couple of things here that are really worth noting right in here. Okay, so you might think things are at 0, but maybe they're at some non-zero value, but it would be, equally invalid, like -10 feet, for instance. And if we do everything in plan view, we're never going to see that. So we're going to learn to use this 3D viewer, and that's going to really give us the best grasp of this once we learn how to use that viewer. And it becomes almost second nature if you use it enough, but it can be very hard to use later, or to use it first. So we've got some points. We're gonna, over here, that steps you through the exercise. You're going to get stepped through all of this. See these boundaries where we put boundaries on the data so we don't have those edges. We've got, here's our triangles that we're left with as part of that surface, again in the 3D viewer. Okay, and then we use another tool called a quick profile to be able to look at this, and it's another way to check the validity of our data. And then at the end, we've got this putting it all together type of thing that leverages everything from, we've got a bunch of points. How do we create coordinates out of those? How do we then make a model? And then we're going to cut a little borrow pit into that stockpile. And then there's our model. There's our borrow pit. Here's the resulting. If you see the existing contours underneath here, as our design contours there. And when we put that all together, there's the design contours merged into these existing contours. Okay, so because that's what the ground looks like after you create that borrow pit. And then it shows you how to do a real simple little center line and profile road design. Okay, so no, we're not going to get through all of this stuff, but the exercise steps you through it one by one. And then you can even, model this as an image. It's a kind of a poor image. I apologize for that, but you get a sense of it from looking at it. And there's actually, if you were to look at that, it was supposed to be gravels. It's sort of a, there's a texture mapping that you can use. So a final graded surface contours and then with the texture applied. And then that then starts you on the rest of the manual, then becomes that command reference. But this whole thing is sort of the entire process of everything you do. The rest of it is all just specialization. Okay, so we're going to jump into that exploration about break lines and modeling with this other drawing. Okay, so let's go to our Carlson software. Go ahead and load it up, and I want you to open a file from your data set called sample from T3 global. And it's actually going to, when it comes up, look something like this. Let me know if any of you have problems finding this or getting it loaded. Okay. Once you get it loaded, just give me a thumbs up or something. Okay, everybody's got it, or Lacey's got it. Josh. Okay. Bill. Shmizy, I'm sure you've got it. Yep. Okay, doke. Shmizy, you've seen all this before, I think. I can't remember if we covered that in that 3D machine control, but in any case, it's a good set of data. Now, what we have is what the photogrammetry firm delivered, and they would typically deliver this in this in this particular fashion. It would usually be done. I'm going to freeze layer by pick right there, turn off those white things. And so they would usually send you something like this. And there's my contour line. See, I've got a 1315, a 1310, a 1305, and then all the ones in between. Okay, so they've gone ahead and created contours. And in fact, if I were to see, let's just open this up even bigger. This might be what you would see, as part of a drawn map with notes and north arrows and things like that. Let's see here. That's all right, dashed. That's fine. Why it's not going up? Let's say PSFT scale and SFT scale. One. Scale now is 1. There we go. Now, if you want to make this to match what your what you would see in over here in the paper space. You could do it like this. There's no need to do. We're not going to work with that very we're not going to work with with this in paper space. But I just wanted it to match. We're going to do everything over model space. So this is really what you would what you would probably see from a photogrammetry firm. They would show you contour lines and building outlines and stuff. Usually, usually in 3 dimensions. You see a few selected spot elevations, but you can also see, what looks like beard stubble around the edges. Those are the actual points that are there in the data. So I'm going to go back to my model tab now. You won't have that same layout tab. Yours will say layout 1 and it will just be generic. But here's what the data usually gets delivered as, something like this. And they've either taken all of this data, which these are all the break lines that they put together. They've either taken all that information and deleted it from the drawing, or they'll put it on a layer and freeze it so that you can still have it to work with. But this is what is defining our surface, those things. Now I'm going to look at 2 things here. I want you to do the same thing. I want you to take the layer approach. We're going to go to the view menu and choose isolate layers. Okay. And then I want you to, as it prompts you to select an object, go over here in the drawing and pick one of those main contours and one of the intermediate contours. And then also go over here to the side, right beside that, either left or right, where you see the dashed contours, and get one of each of those. That's all you need. And now hit enter. And then what you're left with are just the contours. Now, sometimes, particularly you in the construction business and the contracting business, sometimes this is all you have. In fact, they give you the contours and they don't even put them at the right elevation. They just give you the labels, and you have to go through and raise all of those drawn contours to the right elevation before you get data that you can go to build a surface from. It's really the worst possible way to get you the data, and it opens up the door for a whole lot of errors. But that's what happens in our compartmentalization that we do nowadays, and it comes out of the people who are tasked with generating these first stages not being either confident that they've done it correctly, or not being willing to share what they've done because they think they need to be paid multiple times for having done the work once. Really, the client has already paid them to produce that information. And to me, my way of thinking, that information is now available. Somebody has already paid for it. And if it needs to be shared downstream, that's going to prevent problems later. That's going to help a contractor build that better than if I take all of the intelligence out of it, dumb it down, hand him a piece of paper and say, good luck, because I don't want to get sued for liability. So, that's an entirely different class in legal ethics. We'll get to it later. But anyway, here's the case. Here's what we typically have as our elevation information. And sometimes it's all we have, and that's all we can do is build a surface from that. And this is sort of inaccurate, as we'll see here in our discussion about break lines. Now, what I want you to do is, once you have that isolated, hold the shift key down, press and hold the wheel on your mouse, and keeping the shift key down and keeping the wheel pressed in, push it up, push the screen up, okay, and then you can, you know, keep doing that kind of thing, and you can sort of spin this around, and you can see that that is indeed at 3 dimensions. And if you turn it around at some angle, and then you can use the wheel to zoom in and out, you see how you can look at that and say, okay, I understand how that landform looks. I look over here at these ponds and I see, okay, there's a little flat spot, or maybe even it's a perched pond is what it is. It's a pond that's created here above this larger pond. Okay, so, and I can see things like, you know, and I infer things like right in here, even though I don't see anything drawn, but I see what looks like a, you know, a pretty steep sloped surface right in there. I've got, you know, what looks like a filled pad over here. And I've got, just because I know what, you know, road contours typically do things like that, I've got ditches down the side of the road here. I've got, you know, the crown of the road this way. I've got the edge of a gutter here, and a flat sidewalk, and then it starts to climb the hill. Okay, so I've got some information that comes out of this as a minimum, but that, you see that raised sidewalk there on the right of that roadway. So you can sort of get a sense from that, from the contour lines. Okay, so that's one way. If you type the word plan, P-L-A-N, hit enter twice, we'll go back to plan view. Now I want you to go back to the view menu and choose restore layers. Now go back to view menu and choose isolate layers, and this time pick one of those white lines. They look sort of random. And you're left with this. And let's go through that same exercise. Shift, hold the wheel in and spin this thing up and around. And you can see, well, that, you know, I've got some of those very same structures. I don't necessarily see things as clearly as I did with the contours, because, you know, I don't see, for instance, parallel contours running down this sloped surface. I can really, though, infer the slope from the shape of these. I see this near vertical wall right here, this guy. I see it a little bit better using this edge or using this data. But look at these curb structures and my pavement. Okay, so those are all you know, pretty nicely defined. I can tell that those are curbs. They're asphalt rolled curbs. They're wedge curbs. Okay, they're not the square type curb. I go over here and I look at that road edge where you saw those sidewalk, where you saw that raised sidewalk, and now you can tell, well, oh yeah, see, I can see how it walks over there to the edge of the road and steps up that little 6-inch lip up into that little sidewalk area. So these are actually the brake lines. If you select one of those, or if you just hover the mouse, I think I may have turned my, yes, Josh, go ahead.
Hey, I had a question. Somebody was asking me in the office. How did you get to the white contour lines? I'm sorry.
These lines here?
Yes.
Yeah, okay. These are the brake lines. And so what I had and what I have with this information is, let me go back to resetting it. I'll do it on here.
Yeah, sorry about that.
No, no problem at all. I'm glad you stopped. So if I've got everything's shown, I went to the view menu and I said, isolate layer. And I
Isolate
did-
layers.
Yeah, and I picked one of those and then I hit enter. And so now there's that data. So the point is, either one of those methods, if I look at just the contours, or if I look at these white lines, or I'm going to actually restore everything again, and then I'm going to isolate actually both that and that and that and that. So now I've actually got, all three of them, and you can really see how they created those green and yellow contour lines from those white edges or break lines. In fact, if you look at one of those white edges, you can see over here, it's on a thing called VKLN as the layer. That means V means survey, topo, of course, topography. VKLN is break line. And by the way, in case you're wondering where the V comes from, is survey. It doesn't stand for survey, while other layers like C dash stand for civil and A dash stands for architectural. The reason it's V instead of S is because the structural engineers got to the list of layers before the surveyors did, and they claimed the S for themselves. That's the only reason for that. But now you can see these structures very well. And you see how that contour line comes over here, hits the face of curb, climbs up the curb to the top of the curb, comes across the back to the edge, and then starts to climb the hill. Okay, I'm not, let's see here. So that's some of what we're after. And if we do something, if we just build our model, look at these green contours along this road edge, and you can see right, if I'm looking at this, that's the bottom of that ditch. I come off of, this is the edge of the pavement and comes down here to the shoulder, and then it starts coming back up in the up to here, on up the hill. I can see that when I spin this thing around a little bit to see it. So that is what I want to try to do. Now, what we talked about in the break lines. Yes, Lacey, sorry, I just saw your hand.
That's okay. Can you show me how to, I must have pressed something wrong, that green contours back in?
Yes. I was, I had everything thawed, and I was back here, and I said, and I turned everything back on. And when I said isolate layers and we got the white lines, remember we did that. We also did the same thing with just the green lines. So
Yeah.
I just went back to view, turned everything on, and I said isolate layers again.
Yeah.
And I chose one of the white lines, and before I finish selecting, I now go over and get one of the green.
Okay.
One of each of those, and then also over here to get these are on different layers because there's obscured. Okay, so that's all it is. I'm just telling you which layers to isolate. All right,
Gotcha. Okay.
Yeah.
Thank you.
you bet. All right, so now that I've got a good sense of what this looks like, here is how our discussion on break lines was talking about. Remember, we said every point, if you look, back over to, let's go back to here. See, every point is occupied, and you look around it, say on this 110, maybe this is the edge of the road that runs like this, if you can see how my mouse is going. And down here at the bottom, that's the bottom of that shoulder, down at the bottom of that ditch. And then over here is the other edge of that point. So every point gets occupied and looked around itself in a circle, and if it can see with nothing in between it, it's free to create an edge. Well, we need to do something like this right here, create that edge. And that is what this line right here is doing. That is that edge. And that would prevent points, say, on this side, or let's say not just the contours, but let's take each of these. So if I put this line, if I put this middle line in first before it starts to build triangles. So when I get to this line over here, I'm not able to look up at that point and see that point and say, hey, that's, I'm going to draw a triangle edge up there. And that would be, I'll show you that as well. So you can see what I'm talking about here. See, I'm not able to. I'm not able to do something like that, you see. If I didn't have that break line, that would be possible. But because I have the break line, what happens is those two lines wind up doing something like this. Oops, well, not that. I want to add a polyline, so I'm going to put here. Okay, so because that line's there, when I'm sitting on this point, I can't see this point up here. I can only see down here to this edge. That's as far as I can see. So I could be putting triangles together that way. And then when I'm down there, now you'd have to pretend this one's gone. I should have pulled this down here. But then I can go from here up to this side of the back. So now when I'm looking at this, it's going to be even a better definition. In fact, you can see this needs to have this. Let's see, I did that. That's what I did do. Use the right tool again. So I'm going to go from there to there. And we're going to go there. There we go. Now, so instead of now running the possibility of going from the edge of the pavement up here to the top of the bank and not modeling that correctly, you know, which would be shown like this. Okay, so really the reality of it is it follows along those red lines. Okay, so it needs to go down to the edge and then climb up to the rest of the edge instead of that set of yellow ones. Those are the way the triangular pieces need to form. Okay, so thankfully in this data set, We don't have to create those break lines. The photogrammetry company did that already. They loaded this up into 3D stereoscopic viewers, and they put that little floating point down on the ground in their model, and they created all these things and said, hey, there's an edge, here's an edge, here's an edge, here's an edge. And then they let their computers read all of those edges, and it started forming triangles. And it built a surface, and then these contours were simply created from those triangles. We did not create triangles from these contours, but sometimes you are forced to do that, and here's what happens. Remember I said you get you sit on every point and you start to look at your data. So what happens is, maybe I'm sitting here at this point, I'm looking all around it, and I can create, I can do this right here. If I'm sitting, sorry, I need to be back in plan view. There we go. So I'm sitting. Sorry, bear with me. Okay, so I could be sitting here and look up here and see that one. That one's fine. I could also be sitting here and I would look up here and see this one. That one's fine. I could also be sitting here and even look down and see something along along that own feature. That one's fine. Could be sitting here, look over to this side. So these are all very valid possibilities. I wouldn't be able to, I would see, something like that. But here's something that could potentially happen. Okay, I could be sitting on this triangle. Now let me put this back a bit. All right, so I could be sitting along this feature, and every one of these lines, I'll get one more possible. I could have here. Okay, so these if I considered this as a source of my data, when I'm sitting on each of these points and looking around in a circle for other points, when I was sitting here at this point, and I look up here and saw that point, that's correct, okay, because I go from this elevation along this contour down a foot to this elevation to this contour, and all that's valid. Okay, I don't have any evidence of anything in there in between to say anything's different. But as I'm looking at each of these points, I can consider this one, consider this one. I can't see beyond those two. So each one of these, I'm looking here, and all of these triangles that can form between one to the other are all valid. But once I get up into this region here, it can, if nothing else is in between, like that break line there, if it's not there, there's nothing that prevents this point from looking across and seeing this point. And so you wind up with Up here a little bit, you wind up with, you know, something like this where you can see how that ditch gets sort of filled in. It goes from the edge of the road up here to the same elevation. So those are all considered flat triangles because this is all one constant elevation. So all of these triangles are flat, and they're not really. In reality, they go down to this edge and then climb up to that elevation again. So if you consider, let me just see if I can do a, so it's somewhere, yep, okay. So if you consider, so what was thought process was, so I'll get back to this. Yeah, if you consider only these if I'm trying to build a surface from these contour lines, which, and again, as design engineers, you don't do that as often as you would if you're a contractor, because contractor, that may be the only thing he gets is this contour map. And so they have to go back, and they're going to build a surface to start doing their machine control. They're going to build a surface out of these contour lines. Well, that's going to be sometimes the only thing you can do, but that really, to do it correctly, you have to consider the errors that can cause. And these are some that we're talking about. If I'm looking at this contour only, all right, so it's got elevation, so it's going to be considered. But when I get in situations like this, where these long contour noses are supposed to indicate like going up a valley line or across a ridge line, once I get in here and I get past this other one, I can start shooting across and making these flat triangles. And that is invalid. You know, maybe you're just looking for mass bulk type earthworks in general, and you don't really need all that kind of detail and refinement, but we usually do for a good design. We don't want to have our bulldozer go down there and start chattering the blade as it tries to stair step that ditch line. Okay, so we need to figure out a better way of doing that. So what we would have to do, and this would be a situation where we might have, you know, again, if this is all the data we're given, or let's see. Yeah, if that's all the data that we're given and we don't have these, and I'll go ahead and spin this up a little bit. So you see, I don't have these road edges down here all drawn down at 0 elevation. So I don't have anything that tells me that when I'm sitting here, I can't look across and see these other edges. Okay, so that makes those flat triangles. So if that's all the data I'm given, if I've got a flat triangle that goes from here across to here, let's put that in so you can see it. And maybe it goes to there. Okay, so that might be one of the triangles that forms where, and up here might be another one. So what that implies, if I look at this and I'm going to hover the mouse here in the grips and look down here in the right and see where the elevation is. You see that's a 1311. This one is 1311. That's 1311, and that's because this entire contour line is also 1311. Okay, but what is the elevation of this ground really? If this is 1311 and this is 1310, what do you think the elevation should be, like right at the midpoint of that? Like say 1310.5? Because I go from 10 and I walk up that ditch line and I get to 11. So about halfway there, I should be at 13.5, but I'm not. I'm calling that 1311. It's 6 inches too high right in here, or right in here, or all these different places. So that's why I need to use those break lines and have to create them. And that's also why if you get that from your uh, from your surveyors, and that's all they give you, or the photogrammetry firm, you need to be able to create the break lines yourself. You need to start putting those edges in, and thankfully they've already done that. And so what we'll do now is it's come up on our lunch break, so we're going to go ahead and take the lunch break, and when we come back, we're going to learn some techniques on how to create some break lines. It would not be a practical exercise with this data set because there's just way too much I have to do to model it totally correctly. Although sometimes you might have to, but usually in this case, I would send it back to whoever gave me this data, and I say, you know what, give me the break lines, or give me the surface file, give me the triangles that you created, so that I don't inadvertently create some errors that are going to cause problems in construction. So that's really what we're trying to, that's what we're after, because we can share all this data. You may have noticed things like, you can export these land XML files, which are the same as, and that takes care of all kinds of data, not just the surfaces, but you can see from our surface, do I have the surface utility, like export surface data. See, I can export Trimble and TypeCon machine control files. There's ways of getting this stuff shared back and forth with other people and for other purposes. And that's what we want, is not to have to reinterpret everything and potentially cause some errors. Okay, so we're going to learn how to manipulate that. We're going to get a little bit better, or actually, in my opinion, a whole lot better viewer than what we have in terms of just holding the shift key and pressing the wheel down. Okay. Let's see, Josh, I just noticed you sent me a chat here earlier. Trying to draw points in.
Yeah, I ended up figuring it out.
Oh, okay.
Yeah, it was a while ago, but I did figure it out.
Yeah, okay, yeah, see, back at 10:40. Yeah, sorry about that.
Yeah, no worries.
But that's perfect. Glad you said it. And if that happens again with any of you guys, if you send me a chat and I don't do it, just I can see you do a hand raise or something in the window easier than I can see the chat flag. Or feel free to turn your mic off and just say, hey, so throw some kind of shoe at me or something. All right.
All right, yeah.
So anyway, let's put a bookmark in it. We're going to come back at 1 o'clock or at the top of the hour after our lunch, and then we're going to learn how to manipulate and make these surfaces and some tools to evaluate them. And I'll point you to some resources, and I'll show you some other really good and interesting and valuable tools potentially with what you're seeing and what you're using that can really help to clarify your work. And particularly Jimizzi, I saw that you had I guess was it Google Earth that you had up yesterday on your computer when you did your share. So we can get some Google Earth imagery and put it behind all this data. And we have some tools not included in the standard package, but they are available that can help really tighten up that data, because Google imagery is not all that accurate. It's within 5 or 10 feet. Sometimes it is very accurate. If you're in a flat part of the world, you have better chances. But in any case, there's some really nice tools that I can show you about that we'll wrap the day up with. Okay. So enjoy your lunch. I'll see you back at top of the hour. Okay, everybody, I'm back. If whenever you are, let me know.
I'm here.
All right, Josh.
Back.
Hello, Miss Lacy. Welcome back.
I'm here.
Okay, Bill. Mizier, whenever you're there, let me know. Okay, welcome back, everybody. I hope everyone got fed or at least got caught up on some work. Anyway, so we've been talking about modeling terrain by using point and line work information of things that are at a particular elevation. And if we look at if we look at a typical data set, like you see with this sample from T3, you see that there are some things that are drawn at elevation. Let me turn back on those break lines. And some things are not. So the etymology of this, if you will, or the history behind this was that the photogrammetrists built this file from this three-dimensional data that's all up here, which includes, you see those little dots, those are a bunch of points on the ground that they, just as if you had surveyed this, you had gone out there and shot every one of these points with a surveyor, you know, with a GPS receiver or with a, you know, reflector and a total station. And then you notice, okay, well, here's, you know, these are all things across this flat area, no big deal. But I get over to this, and this is an edge. This is where it turns and goes downhill. So, you know, then they connected all of these dots together and made that edge, same as along down the pavements and such like that. And so they took all of that data and they built a terrain, which is like this sheet that hugs to the ground. And then from that, they were able to generate these drawn contours, which are just reading that model and then drawing on the model the lines of constant elevation. Okay, that's all in the world that part does. So contours aren't the surface, they're just a picture of the surface. Okay, likewise, so are the break lines. So now, what happens if we're a contractor, we get a contour map in from a surveyor or from a photogrammetry firm, and that's all they give us. And so sometimes it even comes in and it's flat, everything's at zero. So we have to say, select this one, and we go to our properties and we change its elevation to 1335. We do the same thing, make this one 1334, 33, etc. Okay, so that's sometimes what we have to do to create that. Now, there are some things in some of the other modules, like in civil or construction, that you can say assign contour elevations, you know, from the labels that'll read text and assign the elevations. You can do multiple contours in series. So if you start down at the bottom of the hill, click and go up to the top of the hill and say, I want to start at this elevation and go up or down by 2s, by 5s, whatever. So there are some things that can help us get to that a little more quickly. But in an ideal world, you're going to get the raw 3D information, which includes all of those get this around, which includes all of these, oops, break lines and those spot elevations that you can see here as purple lines. Okay, so that's really all we need to form the triangles. So if we take a look at this information, I'll show you the distinction of what we're going to see the effects of. If you will turn everything back on, let's do this. We're going to go over to our current layer status and let's change our layer to be let's just put it layer 0. Okay, just so we can draw something. Now, what I want you to do next is we're going to draw a rectangle. Okay, so we go to the draw menu, draw a rectangle, and we're going to draw just a rectangle that looks like it goes from here up to about the middle of all this data. Okay, so we get about the bottom quarter, the bottom left quadrant of information is what we have. So there now is the little rectangle. I'm just doing that so I can limit what we're going to model. Okay. Now, let's isolate layers. So we go to view, isolate layers, and zoom in and choose the rectangle and one each of the two different types of contours. Okay. Now, this is going to be able to illustrate a couple of problem areas and what we can do to fix them if all we have are contours to start with. Yes, Josh.
It's getting rid of like the whole rectangle, and I don't.
Did you put go back and turn everything back on?
Okay, so
Did you select the rectangle when you said isolate?
I hit draw rectangle.
Yeah.
And then all right, so I go to isolate.
When you isolate, I want you to select the rectangle as well as the contours.
Okay, all right, yeah, that's what I didn't do.
Right.
All right.
All right, so now we're just going to use that as a boundary just to limit our discussion here for a minute. To show you, to introduce this idea of a boundary. Even though we got data outside of that, this is going to illustrate a couple of points. So we're going to actually build a surface. And we're going to do it several times in several different ways so you can see the effects of what happened when you do this. And this is all going to be done under the surface menu called, in a process called triangulate and contour. It's really two separate processes. It's going to create the triangulation, it's going to build the triangles, and it then is, if you so choose, going to be able to draw the contours that result from that triangulation. There are people who use Carlson software who don't understand that you can make those two different things. And so they think every time they build a surface, they're going to generate contours, but there's a switch, you can just turn them off, in which you just save the triangulation file, and then you can come down here to, you know, two commands below, and you can contour from the TIN file. So you can go out and read any TIN file, and even if it's nothing in your drawing, and you can generate contours from it. But anyway, let's take a look at it. So let's go to surface menu, triangulate and contour. And we see that we have 4 tabs across the top where we have some settings. Now, the first thing I want you to look at is the far right tab that says selection. In it, this is the way to also further sort of decimate your data if you don't want to try to figure things. And let's say if you wanted to, you didn't want to use those pink spot elevations, which are CAD points. You could uncheck that, but you wouldn't have to freeze the layer or deselect them. You could simply still go ahead and select them and it would just ignore them. Okay. So, or you could say, well, the only thing I want to do is just to read those CAD points, in which you would, uncheck everything and just turn those on, turn off your 3D polylines and lines if you want. But by default, that's what it is. This is also the way you can read from a text file or a CRD file, just a mass group of points. Not my recommendation as a good source, but sometimes it's all we have. So, but for right now, I'm going to make sure that you have those top 2 boxes unchecked, or if you only have 1 box, if this inclusion exclusion is not in your dialog, just make sure you have the other box unchecked. So I'm going to do that. That's going to make sure I am able to select everything. Okay. Now, if you look at each tab in turn, triangulate, that governs the process of triangulating or creating triangles. The next 2 govern whether or not you draw contours. There's the contours. And if you choose to draw, let's say I've got this unchecked, so I'm not going to draw contours. So all of this is gray. Also, the labels are also gray, and I can't even uncheck or check to label contours because there are no contours to label. So if I go back to my contour tab and turn on to draw contours, now under labels, I can choose to label them or not. And there's things like, label with index contours, how many feet, how often do I drop a label, what layers, all that kind of stuff. We're not going to label them. I'll go ahead and leave the draw contours on for right now, just so you can see them. And let's put these on layers. CTR and CTR index. And we're going to put our contour interval at 1. And we will check to, yes, we do want to draw index contours. That's what our CTR index is. Our interval up here is 1. That sets this one to 5. Make sure it says contour by interval in the upper left. I would leave all of these 4 options unchecked. And let's leave our smoothing unchecked. And next, we're going to go to the triangulate tab. And this is where we set up the boundary conditions as to what to read, what not to read, how to behave, how to react. Okay, so the first thing is we're going to leave everything unchecked up here at the top, except for right triangulation file. You're going to almost always want to save that file. And over to the right, after you check that, is a select button. Choose that. Make sure you're in your data folder, wherever your drawing is or storing things, and then just give it a name. Now look up here at the top stripe. It's select a triangulation file to write, .tin and .flt. That stands for triangulated irregular network, or fault, a fault file. And that was one of the old versions. It's a non-binary version of a surface representation. So anytime you are in this file, open or save dialog box, read that stripe. It gives you some information, and you see those possible extensions that it might be looking for. You don't have to type them, but it just shows you what it's there for. All right, so now I'm going to call this file EG-1. It'll stand for existing ground -1. And I'll save that. So it's now allocated a spot to put that surface information. I'm going to leave on use inclusion and exclusion area. I'm going to check that on. That's what we drew with this rectangle before. That's going to be our inclusion area. Okay. And the boundary method, how do we want to do that? Now, here's what's going to happen. I'm going to start generating triangles that span the edge of that boundary. What do I want to do with those triangles? Do I want to look at those triangles, and if they cross, I eliminate the entire triangle, and that would be remove the crossing edges. So if it crosses, just remove the whole edge, or I want to trim the edges at the boundary. So that's going to take, if a triangle sticks out across that edge, it's going to slice it off right along that edge. Okay, so that's going to be my preference. Now, our erase previous contour entities is, and it doesn't mean these contours I've shown you here. It means contours that I may have done any other time I have generated Carlson contours. So for right now, I'm going to change that to current surface. No, you know what? Leave it off for right now, because it also considers this boundary as a current contour, or as a contour entity. So I want to keep my boundaries intact. All right. So anyway, now ignore 0 elevations. I'll have that checked on. Everything else is unchecked. I've got these minimum edges set 2000 and 2000 for interior and exterior. Talk about those a little bit later. I'm going to uncheck this densify polyline or densify break lines. Everything else is unchecked. And so the only thing checked is write the triangulation, use inclusion, and ignore zeros. So I'm going to now say, okay. Now read the prompts carefully, because it says select objects, but read the line above it. It says select the inclusion perimeter polylines or enter for none. So notice it could be, it's plural, so there could be more than one. I could have one down here and one up here in this corner, and those two things will still be a single surface, even though they're separated with an air gap. So I'm going to choose this as my inclusion polyline. I'll hit enter. Select any exclusion parameters, and that might be some area within that that I don't know information about, like what's underneath a building or what's underneath a pond. So you might use that as an exclusion. It just cuts out the surface within that area. I don't happen to have any, so I'm just going to hit enter. And now finally, it says select the points and break lines to triangulate. Well, I'm going to either draw a window around everything or type ALL. You do not need to include the boundary. You can, but it won't hurt. It's drawn down at 0 and it's already been designated as a boundary, so it won't hurt anything. All right, so I've generated, so it's going to look at all of this data and generate triangles on it. And then it's going to trim those triangles at our edge. Okay. So we see that it sort of followed things okay. And when I say followed things, I mean it read these existing green contours and it created these red contours. Now, right in here, see, there's the green contour. There's the corresponding red contour. So it thinks that's level right in there. Same thing as the difference between that contour and that contour. So those 4, 5 things you can see were problematic. Same thing over in here. These did not go all the way up into this ditch as far as the surface went. See, it gets over here and it starts making triangles across to itself instead of realizing that there should be, it's taking this elevation and it's jumping straight across to that same elevation. So right in here, that elevation should really be halfway between this elevation and this elevation, but instead it just says up. I didn't see any barrier in there, so I went ahead and created that triangle. So we're going to take a look at what happens in those particular areas and why we need break lines. Okay. So now, even though we've drawn these particular contours, let's go to edit, erase by layer. Select layers from the screen. So pick one of your white contours, one of your red contours, or whatever colors those happen to be that you generated, and get rid of the contours. Now, here's the interesting and nice thing. Even though we've erased the contours, that surface file still exists. I can verify that by going to surface. Let's come down here to draw surface about midway down, and let's just draw the surface boundary. And we'll say okay, and we'll find our file, hit open, and okay, so there is actually the boundary of the surface that it created. Okay, so notice there are some things. There was something out in here, and I can highlight that, and let me see. There was something, oh, there what it was. It's when I was selecting all of the data, there was at one point something out here that it, oh, no, sorry, here we go. When I was looking at all of the data before I trimmed it, I looked at all of these contours as well as these contours down here. So these contours and these edges were able to draw these long triangles up here to see this, and then it trimmed it off at the edge. So these triangles still exist out in here. That's why this, the boundary of this is still out here away from this data. It didn't follow up this line because it originally, when it looked at all the data, built a triangle out here and then trimmed it off. Okay. So now that, and that, that may have no bearing on anything that we're doing. And if we're not doing any work out here, we're just working on the inside. So that's no problem, no issue. Now, we also know that we have a surface file that's out there that we can use in things like our design pads and pond designs and things like that. So if we and if we work with that, we can also take a look on our view menu, and let's look at the 3D view pull right command, and we have two particular commands. One that, well, and more than two, but we have a drawing viewer. And if you look at that picture, that icon, it looks like a 3-color cube. And in fact, the command that it runs is called cube. And then we also have this surface file viewer. Okay. So the drawing viewer, or this cube, and I have it out here on this toolbar, which is called surface. and I hover the mouse over that 3D viewer window, allows you to view any selected faces, polylines, lines, and points in 3D, colon, CUBE, cube. So that means that's the name of the command it's going to run. Or the other icon is this little blue, it's really a stockpile, but it's to represent a surface. And so that says it will directly load the surface file and run the 3D viewer window, and that's called Cube Surface. Okay. So if you choose the 3D view drawing viewer, it's going to prompt you select objects. So you would go in here and select any number of things that you're interested in. Let's say, let's just do those. You could do them all, but let's just do those. We hit enter, and it's going to go into this other little window. It's resizable, put on a different screen, you can maximize it, and it's going to be one of our primary means of looking at our data. So far, I've had you hold the shift key and press and hold the wheel on the mouse, and that's fine. You're certainly welcome to do that, but there is a wealth of additional information that you can get from this. Not only can you manipulate this and spin things around, but you can give it some artificial vertical exaggeration. Okay, that's 3 times vertically exaggerated, and yet I'm not changing the actual elevations. I'm doing just some different things. I can look at my color by elevation, so I can tell, you know, high spots, medium spots, and low spots. It gives me a sense of what's good. There are some people that's all they ever do is that color by elevation. I don't particularly care for it myself, but anyway, it's there. And you can do, you know, cutesy little things. All right, that requires the non-software OpenGL driver. I'm not going to use it. I'm in that Windows emulation. So, but anyway, we've got all kinds of manipulators that are going on here, and it's just for selected data taken out of the drawing. Okay, I've got some other settings over here that you can play with, and some this thing and this model stuff. I can also, right here, as I've selected that, I can still also add a surface to that. And I can turn the triangles on and off. So if you see right here, you know, these are those long skinny triangles over here on this edge. And I've got some others right here along this edge. Okay. So, and there was the boundary that we did. There's the triangles. I can color them in. I can see the edges or not. Okay. Now we're gonna learn, you know, some of these controls so that it starts to become second nature to you. But what I want to show you is, if you remember those flat areas I showed you about on these contours up in this corner of the road, see right there they are. And I can go back over here. I'm going to drag this little light source over on the right. I'm dragging it around so I can cast shadows and see. So right in here, you can see a perfect example right down this ditch line. You can see a perfect example of how it's filled in the ditch. It did not go all the way down to the surface. It looked across and made a flat triangle over to itself. Okay. Same thing over here. It did not pick up this sidewalk very well. Okay. So what are some of the techniques that we can do to keep this from happening? And the single biggest one is this. We need to put break lines where break lines need to be. I'm going to show you the effect of it here. This is not the way you would normally do it. You would normally do it by going back out to the original source data and doing it out there. But you know, even with the surface built, we're going to be able to do that. I have to get out of this viewer and back into the surface file viewer for this little edit to work. So I'm going to exit this. We go right back to the view menu, 3D view, and at this time I'm going to choose the surface file viewer and load up the surface file. Now, there is that surface, just like we saw it a minute ago. And there you can see those flat areas a little better. And now to be able to also see the contours, in fact, let me go to my model tab. I'm going to look at my surface. And I'm going to make it, say, a pinkish color, just so I can see the contour. Ooh, that's a little bright. I want to be able to see the contours once I select those. Let's see, maybe not quite so bright. There we go. All right, so now while I'm in here, I'm going to go to my model tab, and I'm going to go to my icons at the top, and the second one over where it says add entities, I'm going to click. It's going to temporarily go down and it says select objects. I'm just going to grab everything here, hit enter to come back. So now this is just like I had done before, where I had selected some of the contours and then added the surface. This time I'm looking at the surface and I've added the contours. The exact same concept, except now I can show you the effect of what I was trying to do here, because I now have access to a different tool. When I go into the surface viewer instead of the drawing viewer, same viewer, just different set of tools. And that is when I change to use this arrow, I can now have access to this tool down here called the 10 edit. And I can either remove triangles, swap triangle edges, or I can add a break line, or I can remove points, change the point elevation. So I'm going to add a break line. And I'm going to come in here and I want to double click in this peak right there. So I'm going to add a break line from that point, and I'm going to come down to this other peak and I'm going to double click that. So now you see what happened. That's now a break line. So it kept that triangle that went across there from forming. If I do the same thing here, I'm going to add a break line from this point to this point. And in real time, it's changing this surface. Okay, there's another flat spot. Let's see if we can. Maybe there. So if I then double click here, double click here, it fixed that, double click here, double click here, double click, double click. So it's snapping to these points. Let's say I've got one in here. There we go. And so let's go ahead and finish from here to here, here to here. All right, so a couple of things that are sort of obvious from the contour lines. Because we know how to interpret those contour lines, but the computer didn't. So now, you know, we could go through and fix all of those little problems. I'm not going to. Because we have the data. Okay, but oops. Do that one, so I'm gonna go from here, here, and here, to here, from here to here. So you see that, see what I'm doing is I'm building up that what's actually a sidewalk edge and also setting the back edge. Oops. All right, so you see what I'm doing? So really, the more appropriate way of doing this, instead of doing it here after you've built the surface and trying to do it in the surface viewer, which you certainly can do, what you really think, and to my way of thinking, is the better approach is to do that out in the data and just build the surface file again. Okay, that's really you know, my way of interpreting that as a better way to do it. But you have these choices, you have these options. Let's remove triangles. So I could go in here and remove these long skinny triangles out here on the edges. Okay. You know, so I could do that, or I could have drawn a boundary around it so they never formed in the first place. But so I'm going to exit my viewer, and it says, hey, do you want to save the changes to that surface? And if I say, sure, I'm going to call this one EG-1-EDITED, edited. All right. So now I've got two surfaces. I go to view, 3D view, surface file viewer. I've now got ED edited, and I see, well, look at that. That saved those changes and those edits. There's my ditch line on the left where I did the ads. Here's my sidewalk portion on the right where I did the ads. That's business in the center that I modified. And these triangles on the edge that I took out. Now, the nice thing about this viewer too is I go to model, I can add another surface to it. So I can see where one surface sticks through the other surface. I can even make, let's see. You can turn that on and off by toggling, by double click toggling, as long as this is checked on down here. You can make one of them sort of transparent. You just right click, set the surface properties, set the opacity down so that you can see through it. But that's usually done when you're doing like pipeline design. You want to see where pipes are underneath the ground. Let's set the opacity back up to 100%. So now you can see where my pink surface, which was the edited one, I had made those changes. You can see where they now stick through where the brown surface is. Okay, so the brown surface, you know, it added all of this extra little dumps of material in my ditches and where my sidewalks are. So you can see right away, that's going to give me a problem if I'm going to compute volumes and I want things to be very accurate. I need to make sure I can fix that. Okay. So that's another tool to look at with that. We'll come back to that, don't worry. One of the other useful tools that kind of help you assess things is this, also on the surface menu, called Quick Profile. Now, if you're in the civil module, those that you have other modules, I'm going to switch to the civil module, for instance. This same command under Quick Profiles, there's an entire menu for profiles. There's also, you know, further things on the surface menu, all these pads and ponds and stockpiles and such, some additional types of things, line of sight view sheds. But and the profile menu itself has this quick profile that's, you know, one of our little evaluation tools. But I'm going to go back to our survey module, which again is the sort of base level minimalist approach. And I see that there is no profile menu. So I'm going to pull down the surface menu, and down in the bottom section, everything, this is the entire section is dedicated to profiles. So if I choose Quick Profile, what this is going to allow me to do is to click some points on the screen, and it's going to look at whatever I've said to look at along that line. So I can either use screen entities. Let's go ahead and do that, for instance. If you say screen entities, and then you say leave on, ignore zero elevations, and then let's say okay, and then reading the prompt, this is pick a starting point, or you can use a centerline file or an already drawn polyline. So I'm just going to click over here on the left, and I'm going to draw sort of perpendicularly across to the right. And I could keep going, make a, you know, multiple zigzag, but that's all I want to do is I want to look at those two spots. So now I'm going to see that I go into a split view here. Okay, which along that line, as a quick profile, it went from my starting station of 0, 0 out to this next one. So it's looking at that, and down here it's creating a profile. And notice as I move my cursors, or move my cursor in the screen down here, I can see a little marker up at the top as to where I am. So notice I'm coming down, 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 down. And I remember I chose to go from screen entities. Okay. So everywhere it crosses a contour line with elevation, it's drawing that in my profile viewer. But I hit right down here with my crosshair, and I see I'm right there at the bottom. Now, technically, I should be seeing up. I'm going to go up in here and pull this down a little bigger. Okay, so I should be when I'm right there, right in there. See, I should be coming on down to right here, should be a little bit deeper still. If you see the marker in the top part of the view, and you see my crosshair in the bottom part of my view, but you can see in the bottom part of the view, the profile view of it, that's dead flat. It's the same elevation as it is back over here. Okay, and it stays flat all the way across, all the way across, all the way across until it starts to climb up right in here. Okay. And so all this is doing with this quick profile command, when my source data is screen entities, is that it is intercepting anything on the screen with elevation and reporting its elevation with a little drawn profile. Notice on the right, you've got some controls. You can say, I don't want any vertical exaggeration. So there it is with none. It can be 2 times, 5 times. You can say fit, find the best fit. It also reads for you the slope, the station, so the distance from the start, the elevation, and all of that. You can hit the save button and save a profile file. You can hit the draw button and actually draw into, I'm just going to take the defaults and see what happens here. You can draw into the drawing, what that profile was, and this will stay as a permanent part of the drawing. Okay. Let's see. There we go. So I double click that and it's now in the profile editor and I can see each and every one of those elevations. So there's a lot of functionality there. I don't often, recommend doing it that way when I'm doing profile design. I'll typically be in my road design tools in civil, but these are some of the tools that we have. Now we also have, and I'm going to go back to that same general location where I was. If we run that same command, surface menu, quick profile, and instead of screen entities, let's choose a surface file. And notice I have a choice to load 2 files here. One's the first, the other's the second. The first is the one that gets tracked. The second is the one that shows up by comparison. And these file names stay in here from the last time the command was run, even if it's on a completely different project in another part of the world. So if you need to look at, say, if you want to look at, say, only 1, you don't want to look at 2, then go to this button that says second. These are like select buttons, one's for first, one's for second. If we see the second one, and then instead of picking a surface, we just hit cancel, then it clears that out and it will only look at 1 surface. Now I'm going to go to first and I'm going to look at, as my first surface, this EG1. Okay, I'll say okay, and I'm going to look at it from the same type of perspective where it cuts across the contour line. And I see it's still sort of flattish in there, but I do pick up a little bit. Let's see, I pick up a bit of crown that becomes evident on the roadway. Okay, and you see over there in the right-hand half of my window where it's reporting a 3% slope, now 2%, 1%. So it's actually reading a little bit better of a slope, and that's the that was the surface that I did without any kind of break line edits in it. Okay. I'll repeat that command one more time, and I'll switch to not only that surface, I'm going to switch my first surface now to the edited version, and I'm going to show the comparison with this EG1 version. And I'm going to get that same general area. I'll cut across. And now did I well, guess that's right. I must have. Let's go up here to this area where I actually made the edits. So let's see. Well, you can start to see a little bit of differential in here. Notice the crosshairs are tracking that white surface. That's, and you can see it step up. Right here, where it steps up and becomes that little sidewalk area, and then comes up. It holds it flatter than the red one, which is that initial one. Now, let's see if we can't find another spot where there's a bit more difference, where I made the edits. And that might be something like this. If I choose, because I clicked with points, if I choose adjust the alignment, notice what's happening here as I drag this around. I'm actually looking at this in real time. So I can see some differences. And I can't recall exactly where I made those edits. But you can see in there's again where it filled in. Right in there. And if you can see, it's sort of faint, but if you can see up on the plan view, right there where my crosshairs are in the profile view is right smack in the middle of that ditch, which should be lower than, you see the red line, which was actually, higher up. Let's see if I can, or here it is with no vertical exaggeration. Okay, so that might be, half a foot or more, maybe a foot in there that it thinks is higher. Now, that's an example showing a cross. If you take a peek down the edge, okay, here's what I was wanting to get to. So right in here, for instance. You see on the tracking surface, right in there, some of that's where I added that break line. But if I see it in my profile, you see what it does? It makes that what should be a clean, smooth ditch line look like a set of stair steps. And so that's going to cause problems with my terrain modeling, with my machine control, and with my earthworks calculations, because that really should be a lot smoother that you're going to see with that with that line work. Okay, so that I'm looking at two different files with that quick profile. Just another way to evaluate some surface. Now, how do you create those profiles, or how do you create the break lines rather? Well, you would, if this is all the data you were given, you would still go to this, go to a break line layer, and you would draw a 3D polyline, and you would start going down the, down the flow line here of this ditch. And every time I snap to something with some elevation, Notice down here, you see it's reading that elevation Z 1306. Okay, so there's some, you know, some limitations and some tedium involved. And like, it's not real easy to go around curves directly and things like that, but what you wind up doing is you would create those edges so that they act like break lines, just like I did in the surface viewer when I edited the surface. Now, here's the difference and why I want to do it this way is because if you only do it in the surface viewer, and the way I did that before was view, 3D view, surface file viewer. I loaded up my file. I then, got into my area where I was going to be working, say right over here. And I chose this pointer and I said, add break line. And I started doing things like this to this, this to this, all the way down. Everywhere I thought I needed it. Okay. Until I fixed everything to where it looked the way, I was sure that that was a better going. So that's fine. That could be the case. And then I would say exit. It asked me to save changes, and that's when I called it EG1-edited. So that's what you would do there. But now, how do you know after you've made all kinds of edits? Maybe you changed the elevation of a point. Maybe you got rid of triangles. You don't know what you've done. That's just an edit to that surface. If, however, you do something like what I was doing here, drawing this, I'm going to choose right click and draw order back to the front. You drew in that 3D polyline as a break line and put it on a layer. You could turn the layer on and off so you don't see it, but now you've got visible evidence of what you did to control that surface. Okay? A little bit of a nuanced kind of thing. But to me, I think I would much rather see the results here. Plus, I can also see the results by not just the surface file viewer, but just the plain old drawing viewer where I can see the actual elements that go into making that surface. That's much like holding the shift key and pressing and holding the wheel, but then I can exit and come back out without having changed any of this. Okay. So the reason we're not going to bother with it right now with this file and spend hours trying to figure out how to draw break lines is because we have excuse me, we have break lines already created for us. They're these right here, all of these white things. And if we should try to take to build our surface from all of this data, then we've got plenty. We've got these things drawn as break lines. These are also there. Now, let me tell you something that we're going to encounter with this exercise. See, over here are the ones, these are the break lines that I would have been putting in over on that edge, but they're already there. So we're going to let them happen. Now, remember the contours. We have been right now looking at the contours as a source of elevation information. And those contours or triangles rather, are forming by sitting on each point of these triangles and looking across to each other. Whereas really the contours were an output or a result of the triangles that are forming between this type of data. Okay, so right now you see this line and this line, they intersect, they cross. Now, in an ideal perfect world, that's going to be crossing at the same elevation. Okay, I can guarantee you. Let me just get those things for reference, and I'm going to go to my 3D viewer, the drawing viewer. And let me go as well to this, and I'll set the contour so you can see a little bit. So now you see where it crosses, and in a perfect world, that would be exactly at the same elevation. But I can pretty much guarantee you that if I'm going to put a little 5-time vertical exaggeration on it, and I may see that it is slightly under or over. I can't really see it, but I could pretty well rest assured that they're not going to be exactly to the super millimeter, the exact same elevation. They're going to sometimes be interpreted, and there'll be some interpolated loss between the two. Right, so that's going to cause an error when it's building the surface, because if it looks at this point, say right between this line and this line, so that point right there, if that's not exactly the same point elevation wise, well, it doesn't know which point to use. Now, the system will choose for you. It will use a point. It may or may not be the correct one, and it may be so tiny that you can't see the difference, but it generates an error called a crossing break line, which you can't have. And therefore, when you have all of this break line information, as well as the contour lines, do not get so much in the habit of thinking you have to build surfaces from contours that are already drawn. Because usually what's happened is there was a surface built that somebody used to draw the contours from, not the other way around. And if you can get your hands on that surface, or get your hands on the data that built that surface, in this case, it's all of these 3D break lines. And that's all that I ever really needed to build that surface. The contours came out after the fact. Then that's what you want to use. So choose one or the other. If you have the break lines, they're going to be a better source. Now, let's see, what next do I want to point to is, let's go back into our 3D viewer here in a minute. So, rather than that, let's do this. I'm going to take our little rectangle and throw it away and just delete it. And I'm going to freeze my break line so that all I have is this mapping. Okay, now, if I'm going to build a surface, what tool do I use, if you recall? Go to the surface menu and triangulate and contour. I'll just double check selection, make sure I'm not limited. I'm not going to label the contours. Now, you could choose to not even draw the contours. In fact, I'm not going to draw these contours. I'm just going to let it triangulate. And I'm going to write the file. This time I'm going to keep the file name as EG1. Excuse me. So I'm going to uncheck this use inclusion exclusion area. I'm going to leave my shrink wrap perimeter reduction to none. And I'm going to also do this. I'm going to uncheck this ignore zero elevation. I think you should be able to see that when it happens. And then I'm gonna say, okay. It asks me, is it okay to overwrite the existing file? Sure it is. And now it says, select objects. I read the line above to see what it wants me to select. Select points and break lines to triangulate. Well, it's just everything. Off it goes. I'm gonna get some errors over here. And for right now, I'm gonna exit that just so we can get on with this case. So here's the temptation is that you do something like that. And you had a setting wrong, but I'm not generating the contours. So I don't know what's happened, what has gone wrong. I can't tell unless I look at that surface. So if I do some of our tools like this quick profile and I use a surface file and I'm going to take these and reset those. And let's say I just went from here to here. And I look at this surface and I'm thinking, whoa, what on earth? You know, can you see what's happened? I've got a surface elevation of around 1,300 feet up in here. But then when I'm in here in my profile view, I go from right there and it goes all the way down. You see the crosshairs tracking. Goes all the way down in here to a 0 elevation. Okay. And then it comes back up to the top.
I didn't get that.
Oh,
Could you try again?
sorry. So what happened is that, you know, this is a surface. I can even look at it in my surface viewer once I'm familiar with that. And this is one of the things that I will tell you to always, 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 once you're comfortable with that viewer, you have to go here and use that to evaluate what you're doing. And I can look at this and immediately tell something's wrong. I've got, you know, some areas like right in there that look okay, but I've got some things that are horrendously out of whack. Okay. Now this one's really obvious. And I'm going to choose this icon to, you know, color in or not color in the triangles. So this is something that's, you know, really, really obvious to me. I know what's happened. A couple of other things I can look at. This bounding box is always I think a good giveaway. It showed me, hey, you got some problems. Or you could even have the labels. And when you see the labels, all right, I see I'm way below what I should be. If I'm in my vertical group, I look at my colors. I look over on the side and I say, oh, I'm going from 0 up here to 1340. So I've got something wrong. I've got things that have been used to build a surface down here at 0. Now, it was obvious what we did. I'm going to exit that, go back to surface, triangulate and contour. And this time I go, ah, here it is. I did not ignore 0 elevations. And I can see from, even from my 3D viewer, I can see that I've got that same switch up here, ignore 0 elevations. So I can see that, oh, okay. So there is, let me take this color off. So there are all those things like the edges of the road, all of the curb, all of those things are 2D without elevation, all drawn down at 0. And then the white lines, the break lines that we've been using are these same lines, but they are the ones with the elevation on them. So they didn't strip them down. They just kept the elevation. All right. So now that we use that switch to fix it, we're gonna triangulate and contour. We turn on, ignore 0. It's okay to overwrite. We'll grab everything. Sure, everything. Okay. And now notice there's no error message that came up. So that was good. I now want to look at that surface. And I can set the initial color. A little garish. Let's try. It's one of these. I think it's 83, but anyway, this should work. All right, so now I'm going to set the bounding box off, and I'll set the light source up and to the left. So now I've got this. That was created with only the things that had elevation. And I can even go into this model that I'm looking at, the terrain model. And on my settings tab, I can turn the contours on and off. I can set the interval to anything I want, 1/2 foot, 1/10 of a foot, or 5 feet. And these are creating the contours in real time, having read that surface. They happen to look mostly like the ones that we see. However, we got some issues here. I'm going to turn on my triangle edges, and there you see these outside triangles that probably ought to go away. So if I get rid of, oh, sorry. I want to remove triangle. Okay, again, not not the proper way of doing this, but it is a way. So we can work on trimming up our surface. Now we're going to use surface boundaries here in just a second to create this imitation. Because remember, and down here's some other of these long outside triangles that form, and they have the effect of creating all of those kind of long, or not long, but real close together contours, which are not valid. And here are my actual triangles are teeny. Okay, so in any case, use these tools to help you evaluate what you have data wise. And it's just a matter of getting comfortable with where these things are when you're looking at the data. So I'm not going to say those edits. And so let's learn a little bit about that viewer. I'll give you some pointers that you can practice with. If you go to view, 3D view, and choose the drawing viewer or the surface viewer, remember the difference between the two. The drawing viewer asks you to select things that are in your drawing. The surface file viewer asks you to pick a surface file that you have created or somebody sent you, and it lives out there on the disk separately. In either case, you can choose the drawing viewer, select your elements in the drawing, and then you can add surfaces to that to look at. Or if you choose the surface file viewer, you load up the surface file, which gives you access to those surface file editing tools. But then you can add things from the drawing into that view. It's just a matter of which one you load first. So if you choose the drawing viewer first, and you don't even have to get everything here. So I'm just going to take a portion of it. There that is. And you can see those points. And you can then add a surface that is going to get underlaid or overlaid, whatever the right term is. Now look at here, look at that surface. I can see right away. Oh, look at that point. Also 5 times vertically exaggerated. But I can see I've got this point sitting over here. So I had a stray point in my data. Okay, but it's actually outside of my boundary of usable data anyway. So there's all kinds of useful information that you can get from this. All right, now, so I've got that. I'm go back to my model tab, and I can even open up the surfaces. And if I double click it on and off, I can get it out of the way. So now what does it do if I've gone into this with my data, my drawing viewer? This arrow behaves differently. If I point the arrow to something, notice down here at the bottom of this little window, it's reading where the cursor is. It's telling me the slope of that particular structure. It's telling me if I'm over, say there's an LW, a lightweight polyline on a layer called V topo minor of an elevation of 1337, total length of 207.64. All right, so it's giving you some identification control. And if you double click something, it will select it here. It's a select action for the selected entity. You can either change its layer, set it to a 0 elevation, add it to a selection. Okay, so I'm going to add that to a selection and show you how this is going to work here in a minute. I'll do another one, add to a selection. Oops. Wow, great. And I just killed. That's the other reason I prefer the IntelliCAD version of the software, to be perfectly honest with you, is that it doesn't crash nearly as often. But in any case, sorry about that. So anyway, all I'm trying to point out is that that arrow selector is going to point you or give you some different tools, depending on which version you come in with, the drawing viewer or the surface file viewer. Okay. Close that. Okay. So having selected things from the drawing, the arrow gives us all of that information. And I've also got this little control here. These slider controls, put that back to one. I've got these slider controls at the bottom where I can clip near. So it's going to take things that are closest to me and sort of shave them back, just clip them so I don't, they're not in my way. Or I can clip things from the far side, so things that are furthest to me. I can clip things based on their elevation. If I start at the top and push down, see, I can verify some things that way. I can do the same thing starting at the bottom and pushing up. My hand's going to probably spasm here in a minute. It's all going to go at once. There we go. All right, so you got some things you can do there. You can actually lock the synchronization front to back and top to bottom, meaning if I lock that synchronization, if I do the front, as I do the front, it's going to also do the back. That's the way it's supposed to work. Yeah, you see how these are, as I get closer on one, the other one gets further away. There it is. Okay, so just some little things that'll help you here, and it gives you, you can type in an elevation value or read you what those are. But now, here's the main ways of getting around it, because it's really frustrating if you don't know your way around it. And I'm gonna close that off. I'm gonna go back out and come back, turn these back on, so I've got a lot of data to look at. I'm going to now view 3D view, drawing viewer, type ALL, hit enter twice. And now here's all my data. Now, how do I use this? How do I get myself around inside this drawing viewer? And it doesn't matter if it's the surface by itself or just the just the data. We'll go ahead and add the surface to it as well, just so for point of reference. Okay, now, how do I get myself around it? How do I look around at my data? We'll take those break lines and turn them on just for clarity. And so if this is going to be handled over here on our view control tab. Notice the three tabs at the top: view control, settings, and model. The view control tab is where you do things that will control your view. Surprise, surprise. Ignoring zero elevation or not. If I say no, then all of these things down here below at zero are also going to show up. Now, they're not going to be, you see, it's not, this is a lot bigger than what you're looking at before, until you get like way out here because of perspective. That's that dynamic perspective. Okay. But most of the time, you're going to have that ignore zero turned on. Now, what do we see next? Color by elevation. If I say surface only, well, I've got a surface loaded, so it's colored the surface, but the non-surface entities, the things like those contour lines and these spot elevations, it's really sort of hard to distinguish. There you see those points are all the same color of magenta all the way across. The contour lines are all the same color. If I said all, then those are going to take on the same color as the surface. we'll say none right now, so that each has its own color. Sky, if you want, you can put these different things that sort of give you some cute little visual reference. It's there because, you know, Carlson hired a bunch of ex-Russian programmers that came from the gaming industry to create all of these controls, and so they had to, you know, put some toys in there. That's what that is based on. But you can set the lighting based on your latitude and longitude, time of day, time of year, yada, 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 background color below the horizon, all of those kind of controls. Now, the vertical scale is if you are in really flat ground and you want to pick up some nuances, you can increase this vertical exaggeration. This is a factor of how many times it gets, you know, either blown up or suppressed. If you're in a real mountainous region, you want to see it flatter. Whatever you set it to, it will stay that way after you exit the viewer. If you come back in it later, so you might want to keep checking that from time to time to make sure it is sitting at what you want it to be. Now, this lighting by location and time, and this camera-based light, is going to set the way the light is cast across the scene. If I do that here, since I do have state plane coordinates, I'm going to look at this date, this time. I don't know the zip code out there at this site, but it's going to be close enough. All right, and so that sets the time. I just say, okay. Now, so what that does is it takes this little light right here and sets it to make lighting conditions for my view to be whatever I want to use. So I'm just going to manually set it for right now. So if you think about this in this fashion, an easier way to keep track of this or remember this, if you can think of that little yellow square, that could represent, say, the sun up in the sky. Okay, and the blue part is the sky. But we are, you know, actually we're looking at the round earth and the sun above the earth. So I'm actually dragging the sun around, and you can see if I'm over here in the upper left, so my light source is up here to the left and it's shining onto you know, this part of my model. So my shadows are going to cast in that direction. If I put it directly in the center, that's like directly overhead, like high noon. If I put it all the way down on, say, the edges, well, that's, you know, that's getting toward the sun being down on the horizon, so close to sunset, right? But sometimes it's just easy just to grab it and drag it around back and forth and see how the shadows change. I will tell you this as a little bit of interesting psychology. We are so conditioned by the advertising world that almost always shows three-dimensional objects in print ads as having drop shadows down and to the right, which implies a light source up and to the left, that this is going to look most natural like that. So you see, when I have that there, I see this area down here on the left as a little plateau. I see this over here as a hole in the ground. If you should happen to do it, you know, the other way around, you could change your perspective. I'm not going to try to get you to verify that, but you know, you've, I'm sure, experienced that before, where something looks punched in or it looks pushed out because you're still, after all, just looking at a two-dimensional screen. So that's what those controls are. Just play with them and see, you know, what's going to give you some some best insights into your data. The two icons here on the right, zoom in, zoom out, you know, your wheel does the same thing. You don't really need to use those at all. Now you've got the rest of these controls down here. You've got a hand, which means you're just in pan mode. So if you press and hold the mouse button, you're in pan mode. Again, don't need to do that because if you press and hold the wheel, it's going to pan just like when you're in CAD. So this button that looks like a rotation model, which it says switch to rotation model. And if you have an older version, yours might look like an X, Y, and a round hook, like a 3-axis arrow looking thing, or like the old XY, which is the old UCS icon, and then a black arrow with the rounded hook. Okay. That's going to be our most prominent thing that we're going to use most of the time. That's going to be our navigation controls. These two up in the top, again, are the zoom in and out. The two on the bottom, there is a zoom dynamic, again, not necessary because the wheel rolls. This other one is a zoom previous. Well, you know, once you learn how this navigates, you won't ever need to worry about that. This little picture with the, looks like a fishnet with the holes colored in. That's a toggle. If you turn it on and off, that will toggle the filling of 3D solid objects. Now, when we make a surface and we load it into the viewer, it loads up every one of those triangles as if it were a solid, a CAD 3-dimensional solid. And then it colors them in for us if we want. And so that turns it on and off. And that again stays when you exit the viewer. If you go to your settings tab for a minute and come down to the bottom pull down and change that, if it's not already, to say shade front. Then let's go back to the view control and toggle this so that you're seeing it solid. And then click the rotation model button, the second from the left of the upper long row. And then I'm going to show you how to navigate this, and I'm going to show you what that color the front did for us. Is if you slowly now hover the mouse over our data, you're going to see it change shape. If you get toward the center of the data, you're going to see the mouse look like X and Y with arrows. If you pull it down to the outer edges, like pull it down toward the bottom or over to the right and the left, and it's not exact, okay? It's just essentially when you're over the data and when you're not over the data. So if you're over the data, it's going to look X and Y. And when you're outside of it, it's going to look Z with a rotation. And what that means is, depending on what that cursor looks like, then when you press and hold the mouse button and push the mouse around, that's going to control what happens. So if it's in XY mode and you press and hold the mouse button and you push it or pull it, it's going to move around. Now, if you notice, I can move back and forth and it has no effect. It's only going up and down, okay? And that's because right over here, I've got this lock on. If you unlock that middle icon, if yours is locked, and now you go over there and you grab it and you push up and down, that works. But if you push left and right, it's going to rock it back and forth. Now that may help you navigate your views. I'll leave that to your preference. I'll tell you why I like it here in a minute, why I like to have it work. So the way you want to view your data, let's say I want to look down this edge of this roadway over here to see how well that was modeled. Okay, so I wanted to, but I want to look at it from down here in the street. I want to look back uphill here. I want to look at it that way. So here's how, when you first go into the model, when you first go into the viewer, here's how you get yourself oriented. You can create any view perspective you want really, really quickly, and it becomes very second nature. It's a little odd to get used to at first, but it will become second nature after you use it several times. So if you go into the viewer, and now make sure you're using that rotation model mode, or rotation modes, switch to rotation mode, and you're going to put the cursor toward the middle, and you're going to see it, and you always come in plan view. So when you get to the middle, you're going to see it turn XY. That's what you're looking for. Now, pretend you are standing in your driveway and you're looking at your garage door on your house, and you want to walk up to your garage door and open it. So you, and let's pretend it's not one that articulates, it's a solid slab, so it's going to lay back into the ceiling a little bit, right? So I'm going to put it down toward the bottom, not so much that it changes to a Z, but it stays XY. And I'm going to click and hold the left mouse button, and I'm just going to push it up. Now notice left, right doesn't do anything. That's why I like that lock. So I'm going to push it up, and I'm going to go back and grab an extra little bite and push up again. And I want to lay it back to not all the way horizontal, but, you know, somewhat oblique, mostly oblique like this. And then once I have it laid back like that, and I don't care where it is you want to look, go ahead and lay it back sort of, you know, 75, 80 degree oblique angle. Now let the mouse up, and now put the mouse cursor down toward the bottom. And now when you do it and it changes to a Z shape, if you press and hold the mouse button, it only goes left and right. It won't, you know, if you push the mouse up and down, it doesn't have any effect. It just spins it around. Okay, so once that's done, you're going to spin this around. You're going to get lined up with what you were interested in looking at. And right in here, I want to look down that road and then look up those road edges. So now once you get lined up with where you're interested in, let the mouse button up, point to it, and use the wheel to roll in and out, to zoom in and out, and press and hold the wheel, and you can pan and make some fine-tune adjustments. So, you know, like I said, it will very quickly become second nature. So let's suppose now that I want to go and take a look down, say where this little stream channel comes in. Well, you can do it, you know, no matter where you are and what you look like before. You're going to always, you know, push this up to its sort of oblique there, spin it around. That's where I want to be, right in there maybe, and then you can roll in. Okay, so that is going to help you verify your 3D data, make sure that things are looking like what you want them to look like. You make sure you see these edges over here where I've got, you know, a little gouge out of my stream. That looks like the little spillway from this little flat pond. All right. I look over in this area and I see, well, I've got some probable issues in there. Now, keep in mind, I built this data from the contours, so this is not real good data. All right. So in fact, if you want to see the difference, and even though I had the other surface in there, I can add multiple surfaces at a time and turn them on and off. And so now, of course, I can't see the pond because I trimmed this one, but I can, you know, see that road edge. And then again, you can, you know, use things like the lighting to sort of help verify things for you. Okay. So again, it's something that I use constantly. There's other little tools in it, like on the settings tab, you've got this set the CAD view to a current view. So if you see, okay, I see I've got a problem, but I didn't ever see that in my other view because, you know, I was in plan view. So if you choose now to set that to a particular view, then when you exit this viewer, see, you're in that view. But it's just also equally easy to, you know, manipulate a way around here. So I'm going to just set this back to my top view. So that's how we're going to use that viewer. And what we're going to use it for is every time we do something, like let's freeze the contours. I'm just picking the layers. And that now leaves my 3D edges and my spot elevations, all of these points, that leaves them active. And I'll then use it. I'm going to select everything and I'm going to go to my 3D view drawing viewer, this time without a surface on it, just to make sure everything's there. I don't have any, you know, do I have a stray point somewhere? And I actually do. There's one over here on the side. I don't know that it's in your file or not. I may have inadvertently created it, but somewhere it's over there. Or used to be. Somewhere in there. Oh, well. All right, so again, I'm going to verify it. Now, this is also very important, Lacey, for things like if you're working on design, then you want to verify that what you have created as a 3D edge is actually in the right place. So you'll be able to use this and very quickly visually figure out, you know, whether everything is correct or not. There is an area in this data somewhere that the photogrammetrists did not model correctly. It's right in here. That is supposed to be a head wall for a ditch, and they've got things crossing in there. So it causes a couple little errors if you're trying to recreate the surface. But in any case, we can take it and go from there. The point is to learn to use that as a method of building your surface. Now, what can we do with this? Excuse me. Some other techniques in our surface modeling, and that is to put a boundary on things. So I'm going to go to my layer properties, and I'm going to find a layer if I have it. I don't have it here, so I'm going to create a new layer, and I'm going to call it just BDY for boundary. And I'm going to make it red, and I'll make it a heavier line weight so you'll be able to see it here when we work on it. So BDY, and there it is. Now I'm going to leave that. All I did was create the layer. So if we go to triangulate and contour, which is on our surface menu, and if we leave everything, let's say I'm going to change this file name. So I'm going to, where it says right triangulate file, I'm going to choose select. I'm going to call this one EG-2 this time. And I'm gonna leave everything exactly the same, except this time I'm going to select this data instead of the contour data. Now I see I've got some oh, guess I can't leave that floating anyway. So I've got this error message that pops up. So I've got 5 crossing break lines of 0.3 feet, 0.079. These are some, they don't even show up. They're so tiny. And that's controlled by my settings, how much of a tolerance I'm willing to have. But these are some error conditions. I've got 5 crossing break lines and 2 vertical edges. And you see when I'm clicking on these, there's a little arrow over here in the plan view that shows me where that is. So I can go there, select it, and then I can hit zoom in, zoom out, zoom in, zoom to, oops, bing, zoom to. All right, it's not. Apparently AutoCAD works a little differently here. It's not letting me nest these. But in any case, you could find those and it would zoom you to the area that has the problem and you could then fix that area. So I'll show you where those areas happen to be. Is one of them is right here where this line which is my I've got a 3D polyline. That's the one with the elevation. I've got another one here too, this 3D polyline. And you see they don't quite exactly correspond. And I see that if I were to zoom in here way down tight, you see how that crisscrosses, that overlaps that right in there. And so you need to resolve that or just decide that the error is so small, it's not going to make any difference. But I saw the one when I did the modeling. One of them is like 3/10 of a foot right down here. Okay, and so that is, remember I told you that that head wall. You see, that's where one crosses over the other, which implies 2 separate elevations at the same point. So you would need to go in there and modify that, pull this back to the other side, verify the elevations, and that should have been modeled a lot differently than what we have done here. But this is just a flat out error that happened when the photogrammetrist got in a hurry. Okay, and so they let it slide through. So we would technically fix this and model it a little cleaner. I'm not going to take the time to do that for you right now, but that's what this does. If you simply choose exit, then the model gets built with those. The errors are not built into the model. The algorithm decides which elevation it wants to use and goes ahead and creates the model, which may or may not be correct. That's all it's telling you is, hey, here's a problem. If you say exit, I'm going to go ahead and use something, but you don't have any control over it. That's what that means. Otherwise, we fix it and we build it again. And so now we look at that surface. So we go to view, 3D view, surface file viewer, and we look at EG2, and we're going to verify. Okay, well, our contours look nice and tight. Look like maybe, look at the difference right in here of EG2. Now, here's something I want to show you as well. See those nice sharp curb edges? And look at this structure right in here. Same as like these across the street over there. Those are little retaining walls. And this one, in fact, I believe is a loading dock on that building there. Oh, no, here's the loading dock back in here. But notice how that is very nice and crisp and follows those edges. I look down my road. I've got a nice, sharp, crisp crease. I've got this little sidewalk feature out there now. So all of those things have been faithfully modeled with those brake lines. Look at that difference between that. And if I load the other one up and then go back to, let's turn 2 off. So you can't even see those islands. See this island and this island? From the brake lines, but when I built it from the contours, and over there across the street, you see that? So if I turn that off and turn the contour as my source, they're not even there. Now, may not make a whole lot of difference computationally, but what about if you're doing something with machine control? How do you build these structures if you can't define them? You know, there's just no information in this case. There is information in this case, and that's how we build that surface. Okay, a couple of other things that you may notice here. If I look at, let's just look at this entrance across this parking lot. I see, in fact, I'm gonna go out back into this area, and I'm interested in looking across this parking lot. I'm going to look at that with my quick profile. And this time I'm going to just look at that EG2. I'm just going to go across like this. Okay. All right, so if I look at this, let me turn the exaggeration off. And now you see when I'm back up here on top of the island, I come up to the top of the curb and I come down the face of the curb, but see, it's at like a 45-degree angle. Hits the pavement, comes across the pavement all the way over here, and then it climbs up at a 45-degree angle to the top. Well, that's all perfectly valid in this case because that happens to be a wedge curb. But suppose it's not. How do you, how do you go about making that a non-wedge curb? And there's a real interesting and simple way of doing it, is that you have to take this line, this was our face of curb, and we need to put a top on it. Because right now they've got the face and then they've got the back, but they don't have the top. Okay, so we need to basically take this face of curb and lift it up 6 inches and then build the model again. Now here's the one rub and why I wanted to point this out. in triangulation that uses Delaunay's criteria and that computes volumes by comparing triangle to triangle between surfaces that are superimposed vertically, you cannot have any vertical faces. Okay, from the outside looking in, it has to be leaning back ever so slightly. So when I raise this thing up 6 inches, I have to push it back into the hill, into the ground, in this case, what will be the curb. I have to push it back just a wee little bit, and it doesn't matter how much, it just got to be non-zero. I also can't have it, I can't bring it this way. It's got to go into the ground, not away from the ground. I can't have any what are called supra vertical faces or overhangs. Okay, so just keep that part in mind. So how do you do that? How do we create that? That top. So I'm going to go back to my layer control one more time. And I'm going to make a new layer, and I'm going to call this one C-curbs. And let's make its color sort of this orange coral looking thing. Maybe that's not. Let's give it that. I want it to be distinctive, but I don't want it to be so so close to something else. Okay, so now I've created that layer, and I'm going to copy all of these faces of curbs, or not all of them, but just the ones I'm interested to use for a demonstration, into that layer, so that when I build the model, it's going to now properly reflect that. So I'm going to need to do what? I need to make a copy of this and put it in a different place, both vertically and horizontally. What would you normally do? Let's say if you're building this curb structure just as a mapping exercise, and you had this one drawn, and you needed to make, what's the curb thickness is 6 inches. So how would you make the back of curb? As you would typically do an offset, correct? I would take this line, and I would offset, and I would go, 6 inches in this direction. The difference is this is a 3D polyline, and AutoCAD, or any other CAD system for that matter, they will not let you do an offset of a 3D line. If you're going to offset an entity in CAD, it must lie in a common plane. It must all be planar. And it's not. This goes up and down and follows around different elevations. So he doesn't know how to treat the offset. Carlson says, that's okay. We know how to do it. And so they've got a little routine. And again, it's going to be an edit of some existing data. So I'm going to come down here and I'm going to look at my polyline utilities. And I may have, I'm sorry, yeah, it's underneath there, 3D polyline utilities. I'm going to offset a 3D polyline. Okay. So this is going to let us do it the way we're thinking about it, but it does it mathematically, not exactly the same way as with polyline, as with true offsets. So if I offset a 3D polyline, I've got some different methodologies here. And let me see if this help system has any pictures to show you that difference. Not really, it does, it explains it, but anyway. I can go by interval. I can make a variable offset, multiple offset, constant surface, intersection so that it intersects another surface. If I say constant, for instance, notice how this is all changing elevation, and maybe it is, and it needs to offset to another spot that all has a constant elevation. Like, so maybe this is the line along the ground of a decorative wall, and the wall is level across the top. So you could set that as that top elevation. You measure the ground. You don't ever have to measure the top, because you're just creating a line that is so far, so much of a distance away and so much of a distance up or down. All right, so what we're going to do though is we're going to use interval. This is a more common method where it asks us the horizontal as well as the vertical. And it just makes it basically that constant, or not constant, but consistent interval horizontally and vertically. So I'm going to choose that as my interval, and I'm going to say okay. And so now it wants me to notice the prompt. There's vertical / horizontal offset amount. Excuse me. So it doesn't matter which one you do first, other than make sure you're using the one that it's suggesting. It's saying horizontal. So if I typed V for vertical, it just switches it. I want to say 0.5 feet vertically. And then, okay, so how do I set it horizontally? So anyway, I'm gonna escape that and just take the standard prompt. So now the vertical or the horizontal offset amount, horizontally, I want to be almost right exactly on top of it. But remember, I want to go a little bit on the inside. So I'm just going to say 0.05. So half a tenth. I'm going to lay it back so you can see it. 0.05. Now it's asking me for the vertical amount, and I can set the vertical amount by any of these methods, either set a percent slope, a degree of inclination, or a ratio like a 3:1, 2:1, or just a simple vertical offset amount. Well, I want to make it half a foot, 0.5 feet up. So now it says, okay, select the line to offset. I'm going to grab this first one out here in the front, make sure it's the 3D. And which side to offset? I'm going to go back here to the in-ground side. Select another line. I'm going to grab this one and go over here. Now that's all I'm looking for are those ones. I've got this one and this one, and they were on that layer that I made, C-curbs. Okay, just so you can see there where they are. So now, if you go to surface to your quick profile, and this time choose screen entities instead of surface files, and you look across there, and let's go to a one-time vertical exaggeration. Now you're going to see how it comes across, and now there it's built that top of curb, and it's a much closer to vertical face on that particular curb. Okay, so I'll get over here on the other edge, and you see how it climbs up. Otherwise, remember, it went up at sort of a 45-degree angle because we didn't have that 3D line in there. We only went back to the other. Okay, so now if we recreate this, or even if I want to verify first before I recreate, I want to make sure that that curb line didn't have any problems. And I look at it. It looks ideal to me, makes it a nice a nice square curb, square face curb, as opposed to these over here as these wedge curbs, which is really what this curb is. It's not like they left it out, but just for illustration purposes. All right, so one more time to the well. Triangulate and contour, leaving everything exactly like we had before. We just added 2 new break lines. Yes, it's okay. To overwrite, we select everything and we hit exit to get out of that. Let's now take a look at the surface. So we view 3D view surface file viewer. So we add our surface in. I'm going to go to the settings and turn off the contours. And I'm going to go to the model and I'm going to choose this second icon over, add some entities. Get some curbs. Don't need them all. That should be enough. There we go. So now if I look at that entity here, you can see the wedge curb part as compared to this square curb part where we raised it up half a foot, leaned it back ever so slightly. Okay. Everybody see how that works? How that would work? How that would normally work? A very, very excellent way of designing a parking lot, for instance, would be, I've got this existing ground over here. I want to make a parking lot and I want to put an island in it. Well, I don't want to get into all this tricky stuff about the islands necessarily yet, but if I'm in plan view, I can draw the outside edge of my parking lot and I can draw the shape that that island looks like with true circular curves and all of that. Well, when I go and build this parking lot, then I'm going to, in my design file, I may pitch that parking lot. I may pitch it at a slope so that it drains, or I may even put a slight crease in that slope so that it can, drain to a particular point, something along those lines. But I don't want to have to then try to go and figure out what all of these silly little, elevations are going to be as it follows that up and down. So what I would do is I would draw a line, just a single outline of that curb, and I would do it in 2D at 0 elevation, and I would put it right in the middle of that parking lot. Okay, so suppose I had this out here, this green stuff is my parking lot surface. I would draw this kind of island structure in plan view at 0 elevation, and so I'd know where to put it because my design plans tell me where to put it. So I would put it there, and then what I would do is I would go out to I'd be in my civil module, so I would get to this 3D data, and I would say 2D to 3D polyline, and I would say by surface model. It would prompt me, I would choose that outline, and then it would choose me for the surface model. And the surface model that I would use would be the little temporary surface that I've used, that I've so far made the parking lot edge to edge. And I'm going to take my 2D parking lot and or my 2D island polyline, and I'm going to drop it right on that surface, right exactly on the surface. Okay. And then I'm going to go to the same command we did with our curves down here, and I'm going to start doing 3D offsets. I'm going to go up and back ever so slightly, half a foot. There's my top of the curb. I'm going to then also go back and half a foot back and 0 vertically. So that makes my backup curb. And then I'm going to build a little surface out of just those curb lines. And then I might draw a line, say from the center of this circle to the midpoint here, down to this midpoint, center of circle, down here to the center of the circle. And I'm going to drop that one on this little temporary surface where I've made the island, because once I make that as a temporary surface, from this back line, this inside line to this inside line, that's all, it's not level, but it's flat, edge to edge. I then place this line that I draw in 2D. I go back to this 2D to 3D by surface model. I drape it on that surface, and then I raise it up. I change its elevation. I either drape it and then change the elevation, or when I do this set polyline to elevation, I'm sorry, not. If I do 2D to 3D by surface model, let's see. There we go. Use the current polyline elevations as a vertical offset from the surface. No. There's an option in there anyway that you can add or subtract a value for that line that you're draping on the surface. So the same type of thing is you could draw a line that represents, say, a water line and put it on the ground, but then you want to make sure it's 4 feet deep. So you're going to then change its elevation 4 feet. And even though, because it's a 3D line, but it's going to change the elevation, say 4 feet deep at every point along that 3-dimensional line. So that's how that part works. So then once you do that, and then you raise this line after you've got it on this flat surface, and you raise it up about, say, a 1/10 or 2/10, then that's going, and then you rebuild that structure, that's going to create a mounded area. And then you either merge it into this, or you just recreate with all of the data considered. And here's a very good example. I'm going to make another, I'll show you this real quickly. You don't have to try to keep up, but try to remember this for a later time. If I do triangulate, I'm going to write a file, and I'm just going to call this one parking island, right? And let's use inclusion and exclusion areas. I think this would work. No contours, there we go. Densify every 2 feet and go big. All right. So now it wants me to select the inclusion area. Let me see if I don't know that it's closed. Let's see. Yeah, apparently it is. Okay, good. So now select the thing. So all I'm doing is getting that line work right there. Boom, boom, boom. All right, so I now have a surface that is called parking island. And if you notice, it comes up and back, and then it goes, if I can, it goes sort of, like I said, not level, but flat, edge to edge. So even, this edge has a little hump in it, the other front doesn't. So, but it's sort of flat, edge to edge. So now I've got a good starting point that I'm working on. Okay, now, if I draw a 2D polyline. And I'm going to put it on this same layer. That my color be black. That's okay. And no, I'm not, let's see, if I go to the center of, oh, those aren't real arcs. Okay, so that's fine. I'm just going to I'm just going to sort of arbitrarily go here. Now I would might be a good place to put a thing like so. All right. Vert. All right. That's sort of arcish. And will serve my purposes. Okay. So I think I'll leave that. All right. So if I want to now take that island and give it a little round, I'm going to need to make this part of that design. So I'm going to need to turn that into a 2D into a 3D structure. Well, I need to start that 3D structure on that surface. So I'm going to go to my 3D data menu, 2D to 3D by surface model. There's that parking island. I'm going to select the one that I want to put on there. And here's where that vertical offset. So if I was making a water line, I might say -4 feet. Well, I'm going to say 0 feet. It'll be right there. I'm going to set that on the same layer. Don't need to keep that. Okay. And I'm going to say, okay. All right. So now it's been given elevation at that same spot. So the next thing I want to do is, which I could have done in the same operation, but forgot. I'm going to do a differential elevation change of, say, 0.2 of a foot. Ignore zeros. Yes. This, nothing else. It's now elevated. If I select these 3 items and view it in my 3D viewer, there I can see, and you can see that the ridge line has actually been draped on the original surface, but it sticks up above it. In fact, I can show it even more so here. You see how that, when I get right to the edge, you see how I can look under and see air, see an air gap underneath. Well, heck, let's make it a little more exaggerated. There you can see how it sits above that surface. And that surface is hardly, like I said, it's not level, okay? But I laid that right on that surface, and then I raised it up 1/4 foot. And if you look at the contours now, I'm gonna just, view the surface of parking island. And I see their contours. And let's display them at, say, 2/10. All right, so you can see it's a fairly, even though not level, but it's fairly consistent. There's no obvious crown to that surface. I put this on the surface. I raised it up 2/10. And now when we go and build that surface again, and I'm going to use all the same stuff, except this time I'm going to use this one as well. Oh, sorry. That. Okay, and now that's where I messed up. All right, so now I gather my data and I gather that central line. It's now been built. And if I look at that surface now, you can see the contours have this decided little, you see the shape of the contours, there's a crown to it. And you see right here, same deal. If I turn those off, or let's put it back to 1 for the next time. Turn those off. I'll add those, and now even with a 3-time vertical exaggeration, see there's no air gap because the surface, and you can see that, has now got a rounded crown to it. You can also see it in this quick profile, surface file, parking island. So you see right in there, it's got that raised high spot. Okay, and so if I put this as a 1-time exaggeration, you know, that didn't really need it. It's not necessarily all that flat. It sort of has a right to left fall off, but you can see what you can do and how easy it is with that 3D offset command. When you're designing pretty intricate structures, do it in pieces. Do the outside edge of the parking lot, make it flat, or make it all, you know, one smooth elevation, and then draw all the parking islands in, drape them onto that surface, then do a 3D offset, raise up, you know, half a foot and only, you know, half a tenth to set it back to keep it from being vertical, and then offset the backside of it. Half a foot horizontally, but nothing vertically. You've now built a structure as part of just manipulating some line work. Okay. That puts us at 3:20. So let's come back at 3:30, or at, you know, at 30 minutes after the hour, and we'll wrap up. We'll do some additional surface manipulations. We will learn about, you know, we'll learn how to put a boundary on our stuff and what effects that has, and how to control those, and how to make multiple surfaces and combine them. And we'll talk about some of those resources, and I'm going to show you some really great tools that you might want to consider adding to your quiver of arrows. Okay, so barring any questions. First of all, does anybody have any for right now? Okay, so I will okay, I'm back. If you guys let me know when you're back, we'll bring it on down the home stretch. Okay, Josh is there. Bill is there. There's Jamizi. Give Lacey a little bit, a minute or two more here. Right as I started it back up. Here we go now. Okay. So, and I realize there's a lot of stuff coming at you all at once here, but sort of, I hope are getting some ideas about how these things are getting created, how they're being modeled. Again, they're taking three-dimensional information like this 3D line. They're sitting on each and every point in the entire file, and they're looking around each of those points in a circle, and they're starting to draw triangles from point to point to point. And in fact, you can see how a lot of that happened. If I go to let me see. I just want to do within a certain region. And I'm going to draw a triangular mesh of this one. I will use inclusion, exclusion. That's fine. There's my inclusion, no exclusion. Now there's the triangles that it created. So if I take each of those and I'm going to put them in the background. Okay, so now you can see if I select, say these, you see how it has, the algorithm sat on this corner, looked around itself, and started connecting up to nearby points. Notice this point right here. The algorithm could, or this point over here, the algorithm could have sat on this point and connected over to this point. It did not. It sat and created this one, and it created this one. Now, we don't know which one of those is necessarily more correct than the other. Probably these are fine the way they are, because, you know, really the ones closer to being straight across are the ones that typically get used. But what I want to point to is that notice that this point is not able to look across. There are no lines that cross this edge from this point. Like this point can't look across and see a point over here, which would be there's a point right there. There's these points right here. So you see this point was able to see all of those points, but it couldn't see that point. So no triangles formed from this point up to this point. They all had to stop along that line. Same thing here in the middle. This point can't see beyond those drawn 3D lines. Those are your break lines. That's what makes things like these curves you know, you can see right in here, these triangles here come down, hit the bottom of the curve, and then climb up this 45-degree layback to that curve. Okay, so I hope that you've got a sense now of how this is working. So I will erase my layer and also erase that guy. Okay. So now for some working purposes on some things like computing volumes and doing some grading design, I'm going to turn my contours back on. Now, these are the contours that they drew for me. They're just polylines. I'm going to leave them on here for a minute. And I'm going to go to the freeze or to the view menu, and I'm going to freeze layer by pick, which was that all those white lines, and then I'm going to grab, you know, some of these those little purple dots, so I don't have everything out there sort of competing for my attention. I've got what would normally be close to a delivered map. Okay, I've got all these little labels. I think I might even be able to turn those off. Yeah. Okay, so that's more like what my delivered map would look like. I'm going to use that for some references. You'll see in a minute. So I've got a good surface file now called EG-2 that was built from all those lines, those 3D break lines. Except we had those long skinny triangles out here in the edges. We hadn't talked about that part yet. We'll sort of put a bookmark here and get back to that in a minute. But let's see. I did want to, so I'm going to take this guy away. And here's another difference, by the way. You notice this retaining wall? This right now is just a 2D line, but if I have that on, I've got, you know, there's also a 3D polyline there. And if I look at those things in 3D, see how that, and it works as a break line, so that keeps that surface contained within that sloped edge. If I only looked at the contour lines, you're going to see a vast difference. So they trimmed off the contour lines and they look like this. And so when you try to make a surface from contours, you're going to get in here and you're going to get on this top of that wall, and you're going to look way down here to this other contour line. You're going to get this giant slope, this ramp area that gets filled in here. And you can see that we let's add those two models. G1 and G2. Now I'm going to open up my surface. I'm going to turn EG2 off. And I'm going to look at that right there. So you see what it's done. If I did not use the white break lines, it went along those contour lines, and I got these slope fill in. So there's a lot of material in there that I don't need to be accounting for in my calculation. If I turn that surface on and then turn that surface off and then this one back on, you see how that kept those things from happening? See the difference? So that's why break lines are vitally important to what we're doing. Now, let's talk about the boundary a minute. You saw when we did the initial work, we just drew a rectangle. We told that to be the boundary and it clipped my surface. I want to be able to draw a boundary around all of this so it clips that. So I'm going to now go back to view thaw/on all layers. And then I'm going to freeze layer by pick, and I'm going to turn off my contours one more time. Because I'm going to build my surface one more time, this time with a boundary. And you can do it any way you want. You can simply draw a 2D polyline. And I'm going to, for this operation, turn off my snapping. And I'm just going to go I'm going to turn off my selection cycling. So I'm going to just sort of come along this edge, come down here. There is absolutely nothing wrong with doing it this way. I'm going to come into, where my last bit was, come across here, come across here, and then maybe close. So that's perfectly valid. I can use that if I want. Now you can see this is a fairly small site. So what this is going to do, it's going to keep those triangles that formed across here and across here, those long skinny ones, it's going to clip those out. So that would work. And what happens is when you draw or when you build a surface, let me go back to surface. I'm going to switch back to survey. So when you go back to surface and triangulate and contour, if you turn on this, I'm going to change this back to EG. Let's call it EG3 at this point. If I use the inclusion exclusion areas, no need to densify those really. So if I use those, it's going to ask me to pick those when I select my data. I'll say okay, and it says select objects. Well, I don't just grab everything. I read the line above. It says select the inclusion perimeter polylines or enter for none. So I'm going to select that one. And I hit enter again to finish that selection, and it still says select objects, but reading the line above, it says now any exclusion polylines. Well, there are a couple, like this building, this building, this building, say this building. I don't really know anything about what's under the ground there. These are ruins. That's a flat concrete pad, so it's open. Down here's another building. All right, so I'm going to say those are exclusions. And I'm going to say, okay. It still says select objects. I'm going to now grab all my data. Up it goes. And again, I have those little errors that I'm not going to bother to fix. So now, if I look at that surface file with my viewer, EG3, see what it did? It took the outlines of the buildings and nulled out the surface. I need to put this back to 1. So it nulled out the surface where I put the exclusions. And the inclusion trimmed the outside edges, so I no longer have those long skinny triangles out there. And that's a little bit more representative of what I've got. Okay, now here's another very common practice. You build your surface out to the outside edges. I'm going to take this object, it is a 2D polyline, and I'm going to just do a standard offset of 20 feet. I'm going to, well, let's see, let's make it bigger than that so you can see it. I'm going to offset, let's make it 50 feet. I'm going to go to the inside. Okay, now I'm going to freeze off these 3D lines. And I'm going to now draw my contour map because I've already got the surface. So I'm going to contour from the tin file, and this is going to be that file that I've already made. And it's just like that triangulate contour labels and selection, but there's no selection. There's no triangulation really, other than I'm going to use this in this new inclusion area. And I'm going to turn on my contours, and they'll be red and white this time. I'm not going to label them. I'll just draw those, and I'll say, okay. And it now wants me to pick an inclusion. Now, even though my surface exists all the way out to here, it's going to trim off my contours to just that area. And no, let's see, I guess I still need these so that I'm not contouring through my buildings. And there you see, I've drawn the contours, but and then I would, you know, erase this, and that would be what I might deliver. And now if I turn everything back on, and I'm going to freeze off the white lines, and you can now compare your red and white contours with their green contours. You see there's a couple little differences, but they're tiny. Notice up in here along those road edges, everything, we don't have those flattened out areas along the ditches. We also don't have that weird thing in here. We've got it actually as a well-modeled surface. So that's another way of verifying, because you can compare your contours with what they delivered to you as well. Okay, so I'm now erase by layers. I'm going to select one of my red ones and one of my white ones. Contour index, they're now gone. Okay. So that was, I'm going to turn everything back on. I'm going to freeze one more time the drawn contours that they gave me, because they're just for cosmetics at this point. And let's talk about another way to create that boundary instead of having to draw a figure, which you can certainly do. But I'm going to get rid of that. I can now turn my snapping back on. All right, so if there were just a way that I could say, look at all this data and snug in a line that draws around all this data. And that is on our draw menu, what we call shrink wrap entities. Now, don't be confused with this one where it says boundary polyline. That works like the boundary of a hatch, and that's a standard CAD command. This is shrink wrapping. So if we shrink wrap, And we let it go across gaps because we want it to shoot across these little open spaces out here. I'm going to select boundary as my layer to put them on. And I'm going to set this perimeter reduction to none, just so you can see what happens. I'll create it as a 2D poly. I'm going to say, okay, I'm going to select all this data, and there it goes. Well, it didn't go up into these open areas. It didn't trim that out. And here's the reason why and what that number and where that number gets set. Now I could do a couple things. I could come in here and say, add a vertex, whoops, sorry, picked the wrong. Add a vertex, you know, so I can manually create, you know, the boundary after I've used shrink wrap. I can fine tune it a little bit. I can do it that way. But here's what's going on. I'll go ahead and delete that. And I'm going to repeat shrink wrap polylines across gaps. Here it is, blah, blah, blah. But now this perimeter reduction, I said none. If I say high, watch what happens. So I now select all my data and it looks like this. Well, look up here. It's jumped way in what used to be a fairly straight, but see, there's nothing out here. So it jumped in. And what's going on when I set that number from none to high, that says the perimeter reduction to none, it didn't do any reduction. If I set it to high, it does a whole lot of reduction. And what it's actually doing, when you run that command, shrink wrap polys, keep your eye down here on the command line and watch what happens when I finish this. You see where it says 20, well, it no longer echoes it. The old version that used to, you would see some commands echo down here. What it's really doing is it's building a triangulation model just in memory temporarily, and then it's reducing those perimeter triangles. That's what that term means, perimeter reduction. It's reducing the perimeter contour or perimeter triangles, either none, which kept them all, high, which got rid of as many of them as it could, and then you've got things in between. So if that's a little too tight, you could do it one more time, and you could adjust that from none to low to medium to high. Medium tends to work well. In this particular data set, low works better. We'll do that and we'll see, okay, that's a lot smoother. I could, you know, get rid of a couple of these little bumps. I could even, you know, trim that off there. I could come up here and say, you know, bring this in a little tighter. Just say, put it right in there. I'll get rid of that one. And, you know, you could make some little, you know, you could get rid of these so that it's, you know, so it goes all the way across that gap. So you can make some little fine tuning edits to your polyline. Again, it's just a polyline, so you wouldn't worry about it. So you want to make sure that you set things up, you know, that's the most reasonable. You know, get rid of some of these little stray things. Once that's done, then when you triangulate and contour, use inclusion exclusion areas, you now have this as an inclusion area. You can select it and use it. Okay, so that one you can do. You draw this first, and then you turn this on. Now, there's an even third one that's built in, and you can do it like this. I'll erase that. We'll go back to triangulate and contour. And this time, instead of using the inclusion exclusion areas, I'm going to uncheck that. And it's going to offer to do that shrink wrap reduction for me. And either no perimeter reduction or low, medium, or high. I'll set it back to low. And now I'm going to hit this setup button, and I'm going to make sure that I use a 2D in this case is all I need. I'm going to put it on that same layer boundary. And I can either draw or not draw the boundary. I'd like to draw it so I can verify it. So I'm going to say, okay. I'll say, okay, it's going to have me select my data. Did I get the right surface file? Let me escape and do that again. Try to contour. Oh, I need to write the file. I'm going to select that file again. And now shrink wrap low setup should be just like it was. Everything's good. I'll say, okay. Yes, it's okay to overwrite it. I'll now select my data. There's that exit or the error box. I'll clean that off. And there's that same one as if I had drawn it. Whoop, let me get rid of these contours again. Just one more time. And this time, turn off the draw comment. I'm not going to draw the contours this time. I'll do all this, select my data, close this off, verify that, okay, yes, that's where it's going. And over here, I'm going to say, well, that's okay. I'm going to let that happen in there because I'm not really working over there. I'm working over in the middle. So that part, I'll just leave it on. Okay, and so now, if I turn everything back on, and I'm going to freeze off those, you see, I've got a surface that actually includes data out in these edges. They delivered me drawn contours, but trimmed them off by coming in a little bit and cutting off these outside edges. That's very common for photogrammetry firms to do. They go bigger than they need, and then they trim back to what they deliver. So I have everything that I need. I built a surface. If I look at all of this mess in my viewer, and then if I add that surface to it, and I choose my little controls here, you can see I've got a nice surface that's built. These contours, remember, are the ones I selected from the drawing in my drawing viewer. There's the ones they delivered. You can see how they end at the edges a little bit, but I still know what the surface is out here. Okay, so and I've got this same structure up here. Remember, I still kept that vertical curve in there as opposed to these wedge curves. Okay, so I've still got all of those structures because I used the break lines. I've got that nice little loading dock area there. I've got these islands. They're all nice and well defined. Okay. So now I've got something to work with. I've got a boundary. You can either delete it, or freeze it, or do whatever you want to with it. We can just leave it on, no big deal. So let's see what we're going to do as a design exercise. So I'm going to freeze. I'm just going to grab one of those points just to get them out of the way. And let's do a very simple, we're gonna do a pad design. Okay, this could be the edges of a pond. It could be, maybe we're putting in a new parking lot or something like that. And when you get a chance back here on this, in this set of exercises, this was all the break line stuff that we've been doing. Under this putting it all together workflow, we're going to, this would step you through, you're going to have a drawing here that's just got points in it. Just follow these instructions and you can get these outside points, create a boundary. You got the inside points that are going to make the interior of that. And then we do, so that's the existing ground. Then this is going to be a little borrow pit, sort of like a pond. We put the bottom in and then we offset the edges out here to where it hits the ground. And then we can merge those two together. So we're going to do a similar exercise to that. Okay, but this takes you through. I would recommend that you go through that as an exercise when you get a little bit more time. So let's draw a simple rectangle. And I'm going to put this on a layer. I'm going to go to my layer control. And I want to put this on a new layer that I'm going to call C dash PKGLT for parking lot. I want to build a parking lot. Okay, so I will make that yellow, and I'll just keep the default line width, keep it continuous. I'll make that my current layer. I'll close that away. And so I'm going to draw a 2D polyline. And I'm going to use my current drawing properties. I'm going to say, okay. And I'm going to say, I'm going to start up in here. I'm going to turn my snapping off temporarily. And I'm just going to come sort of parallel to that little edge there. Maybe come down to here. And I'll go across a little bit into this bank. I'll come back to this back side and then maybe close it up there. Let's see. Let me pull this back a little bit further like that. There we go. Just a nice little squarish looking parking lot. Okay. Now, remember when I went to civil and I said 2D to 3D polyline and I set it by surface model and I put this on the surface? Well, I got several ways I can do that with survey. If I don't have the civil module, I can do what's called a pad design. I'm going to design a pad, or I can do a 3D offset, just like I did back before. My 3D polyline utilities, I'm going to offset a 3D polyline. And this time I'm going to offset it to a surface. I think this is going to work. I'm not, let me see if I can do this. Round the exterior corners. Yeah. No, this is not going to work. I can tell from that it's not going to work. All right, so if I'm going to do this as a pad, I want that to be set at a particular elevation. Now I can draw a 3D polyline if I know these corner elevations, and I can just type them in as I go along, or if I look at these contours, like there's 13, 10, there's 15. So somewhere here about in the middle is like 13, 10, 11, 12, 13, 14. So about 13 and a half is about sort of halfway through where this sits. So that's going to, if I put this at that given elevation at 13, 13 and a half, it's going to be into the ground back here. It's going to be out of the ground down here, and I need to tie it into that existing ground. So I could do that by selecting it and setting that elevation right there to make it all level. Or I could go to my surface menu and I'm going to design pad template. Okay. And that brings up, and this is our number one grading tool that we're going to use to set things into particular grades. And so it wants to know what is their source of our target surface. You can use screen entities or a given elevation, or in this case, we could use a surface file. Now, if I uncheck this multiple pad polylines that was left over from the last time, that lets me, so I could set it to a specific elevation, or I'm going to target a particular surface file. Okay. So I'm going to go from this pad to the outside. So I'm going to set this at some elevation and then have it build the tie slopes into this existing ground by going to the outside. Notice if you did it to the inside, you would be, creating like an excavation, like in the case in the exercise, that borrow pit or a pond. Okay, now in the civil module, you have some more advanced pond design tools. But let's just look at this basic level. So we're going to go to the outside and we're going to set our slope projection is going to be perpendicular to the slope direction, not the pad polyline. That gives us our more conservative approach. And we're going to use a ratio like a 2-to-1, 3-to-1, that kind of stuff as a target. Okay. Now I'm going to keep all of these things here unchecked. You can look at your help system to see what these do in another time. And I'm going to only come down here and say round the corners. I'll draw the side slopes. I'm going to color the side slopes. And I'll erase the, well, no, I'm going to uncheck that too. So just these three checked. My side slope spacing, I'm going to go every 5 feet. I've got shrink and swell. I can put those in if I know them based on the soil. I can put subgrades in, topsoils in. I can set a minimum cut and fill height. I can trim any existing contours inside this pad, yes or no. I'm going to say no because I can always draw the existing contours up here and use this as an exclusion area. So I can control that later. And then I'm going to put this on a layer called pad. Let's call it C-pad. And that's really all I need to use right now. I'm going to say, okay. It says pick a pad polyline. So this is the perimeter of the pad. I'm going to pick this. It's a 2D at 0 right now. So I'm going to select it. It wants to know my target. I'm going to use that existing ground 3. And now it wants to know what fill slope do I want on my ground. I'm going to say 3-to-1. And what about for cut areas? Also 3-to-1. So you can control them as different. And now it says the range of existing elevations all along this pad goes from a low of 1302.14 to 1319.38. It suggests using the bottom most, so everything would be in fill. But I'm going to set this to between what I said before, 13 what, 1313.5. So 1313.5 will be the elevation of my pad. Okay, and there is the resulting fill slopes on this side, cut slopes back here on the high side. And you can see, wow, it even went way out here to fill because this bank got too steep and it had to fill this in to keep that as a 3-to-1. Okay, we'll just leave that there and see it. You can adjust the parameters and redesign it if you want. We're going to say no at this point. And do I want to contour again? I'll say no. And just all that I did was create some 3D lines, just like those white lines and these curved lines. Okay. So to work with that, I'm going to go to my view menu and I'm going to isolate layers. I'm going to pick one of those little lines. That's my layer called pad, where everything was done. I look at that in my 3D viewer just for verification purposes, and you can see what would get built if I chose that pad. I have to cut into the back bank, fill down to the front bank. Okay, and that's what would be. Now that makes a perfectly level pad at that elevation. If I go back to view and restore my layers, and I'm going to erase by layer, this time clear, select from the screen. I'll choose this one of those. So it's going to take that entire C pad away, still have my original. And I'm going to do something slightly different. I'm going to go to surface, design pad template, everything like it was before, except I'm going to come down here and say use a slope pad design. And I'm going to slope that at a -2%. Okay. Whatever I choose here, I can put that in. So I'm going to slope my pad 2% down. I'm going to say okay. So pick the pad polyline, pick the surface. There's my fill 3-to-1, cut 3-to-1. And it wants to know the bottom-most elevation. So the range of existing goes from 1302 to 1319. Let's make the bottom, we had 1313.5 if it were flat. Let's just keep that same 1313.5 as a bottom. Now pick the point to define the slope direction. So I'm going to start from this corner and I'm going to go down toward this corner. And now I've got a slightly different shape to it. I'll answer no to those. I will view, isolate the layers, select the pad, and now you can see it's going to look like this. Okay, so I gave it a -2%, and actually I gave it the direction, the wrong direction. That's going to slope it backward. So let's try that one more time. I'm going to view, restore layers. I'm going to erase by layer. So edit, erase, erase by layer. I don't need to pick anything now because the layer is the same. And then I'll go back to design pad template. And I can either pick it in the opposite direction, or I can change that to a +2%. I'll pick it in the opposite direction is what I'll do. So I'll take this, select the perimeter, select the surface, put in my fill, cut and fill slopes. I'll say 1313.5. And now for the direction, I'm going to go this way up to this way. So now I'll say no and No. And if I view, isolate layers, pick one of the pads, you see it's got a little bit different. In fact, it has to, it's raised this corner up here high enough to where it needs to still be in fill. It's in cut over here. Okay, but it kept it because I slanted it in the opposite direction. Okay, so now I've got a slant. If I look at the elevation here, I see that's 131503. I look at it down here, it's 131670. Looks like maybe I did it backwards again. 1386, 1320. So that goes. I'm gonna get a inquiry drawing inspector on, and I'm going to turn on the polyline data and direction. And if I look at that, so going down that way, that slopes down 1.64%. This line sloped up at 1.48%. That line sloped up. So my low spot is indeed that bottom corner. Okay, so that does flow down that way 2%. Okay, now, I'll turn off my drawing inspector. And now, so what do I have? I now have an outside boundary. I have a bunch of 3D lines. So I can just simply make a surface out of this. And I'm going to do that next. So I'm going to go to surface, triangulate and contour, and I'm going to change the name of it. And I'm going to call that name pad. I will check to use the inclusion exclusion areas because I have the boundary already drawn. I'll say, okay, I select the inclusion, no more inclusions, no exclusions. I grab the data and off I go. I've now built, oops. I have now built this surface called pad. I verify it by looking at it here. I could even, superimpose the line work on it, and I can see what it's going to look like as it ties into my existing ground. Okay, so I'm happy with that. So now I've got a pad as a surface. I've got the existing ground as a surface. So I'm going to go back to view and restore my layers. So how do I put that together into a final composite surface? How do I calculate some volumes? How do I do those different things with it? So on the surface menu, if you want to calculate some volumes, there's this volumes by triangulation, and I have two choices. I can use one triangulation surface volume, in which case maybe you've just created a stockpile or something. And so it's going to, if I choose one, it would choose the volume of that stockpile based just on its outline. It assumes it's flat underneath it. But I have the existing ground that's under there. And I also have this new design ground. So I'm going to use two surfaces to compute my volume. Now pay attention when it comes up to this. And it's going to ask you to select the existing surface file. That was my EG3. I'll hit open and it comes right back to another one that looks just like it, but up here at the top it says select the final surface. That's my pad. I'll open that. Now, if I want to use inclusion and exclusions, I could do that. I could draw another frame and just limit it to within that particular phase boundary instance, but because this surface ends here, I don't even really have to pick it. But so I'll just say enter no exclusions. Shrink and swell. You can report tonnage if you know the density of the materials, blah, blah, blah. We're just going to say okay and get the results. Now here's what it takes to build that surface pad. I've got 1,100 yards of cut. I've got 8,800 yards of fill. And that means that to bring this thing to build this thing, I have to bring in 7,600 yards of material. If I want to balance it, if I were to drop that surface by 2.5 feet, then that should bring me closer to being balanced. And it shows me that every 1/10 of a foot I raise or lower that design, I'm going to get close to 300 yards of material out of it. Okay, so to get this closer to balance, let's drop that 2.5%. Now, in civil, I'll pop over here to the civil module to show you. Under surface, you have not only design pad template, but you've got edit pad template. Now, do all of you have the civil module? Does anybody only have survey? Everybody does have civil? Or you're not sure?
Yeah, I got them both.
Okay, Josh, how about you, Bill?
Yep.
Okay, Lacey?
Yes, sir.
All right, Tamizi, do you have civil?
Yeah, I do.
Okay, well, let's do it that way instead. What I would have done in survey only is I would have gone back to that process. I would have kept that number in mind, 2.5 feet, and I would have dropped it 2.5 feet. But this editing gives you a really cool set of tools. So if you'll switch, go to the settings menu. If you don't have the toolbar up, go to Carlson menus and choose civil menu. All right, so now on the surface menu, I can edit that pad template. It wants me to pick the pad polyline, so I'm going to pick that. And it brings this up, and I can change the cut and fill slopes. I can set the elevation to, there's where I could take that 2.5 feet off of there, or, you know, I can even move it and let's say, you know, one of the things I might want to pull this corner back in a little bit. So if I say move a vertex, I'm going to say pull, I'm going to pull this vertex a little over here, and let's move this one. Let's get it off that bank a little bit more like that. Okay, so now I've changed where it is. The old stuff is still there, but if I just say process, it's going to recompute that. All right, so that part was pretty good. I can change that value there and then reprocess, but notice I have here a button that says balance. So if I balance, it wants to know what is my desired import and export number. So if I want to balance them to the same, I'll make them both 0. I'll say, okay. It asked me down below here, find the optimal slope percent grade. I'm going to say no, I'm just going to keep the slopes the same way. And so it readjusts it. It sets the elevation down here to just below 1312. Remember, I had 13.5. There's that 2.5 foot drop. And it recalculates it. And you can see that things have changed in building that pad now. Okay. So that part is already done. And I could then isolate those things and build a new surface, build the surface over again. I can do all that stuff manually, or I can just right here, I can say write the 10. So if I choose that, I'm going to overwrite that other one called pad, and I'll save that. Yes, I can replace it. All right, so now I've done that. It's now balanced, and I'll say exit. And if I select all my pads, I look at them in my 3D viewer. There it is. If I go to my model and add the existing ground as a surface, you can see down here where it's filled, and you can see up underneath where it is sticking down underneath, sticking down through. Now notice it's solid here, it's blank there, I can see through it. And that's because on my on my settings tab, down here where it said shade front, if I shade both, now when I flip under, I can see that surface. I can see the solid part of the surface. So I can see that. I can set my surface properties, give it a little less opacity so I can see through it. So I can see up here in this corner where those areas have to be cut down. All right. And now I have that surface compare that one to this surface. You can see where one sticks underneath the other one up there in the corner and sticks out above it here down below. Okay, so now what do we do to get a final composite surface, a finished surface? We need to take that pad surface and stick it into this existing ground and create a new surface from that. Okay, and that's called surface merging. And we're going to do that with our surface menu, triangulation file utilities. And so that's going to bring up a little thing sort of like our 3D viewer. And we're going to load our TIN file. We're going to load the base file first. So our EG3, there it is. I can color it in if I want to see it like so. And now I'm going to do a couple of things that are over on this next page. So I'm going to click next, and I'm going to merge a 10. I'm going to combine two 10 surfaces. So I'm going to merge a 10, and I'm going to merge in. I'm going to use the second 10 as inside the current 10 outside boundary when I'll create a transition. That's my most common use. You can look at the help system and see what all these different ones do. So you can also, set the colors so that you can see them separately in the surface viewer if you want. What's included and excluded. I'm not going to set the colors on there right now. And so I'm going to do that. It wants me to know which TIN file do I want to join with the current one. Well, there's the pad, and I'm going to open that. And now you can see what would be created when I merge those two surfaces. In fact, that is created, and all I have to do down below now is to check on these three boxes and choose save as, and I'll call it merged. TIN file is saved, say okay, and I will now just go the exit button, either the upper X or that bottom down below. So I now have this new surface called merged, which includes that. I can see the contours and what they would look like. So that would be my final design contour. And you see it slopes down. So I could put a little drainage ditch in here, or I could put a pipe under the ground, that sort of thing. One way to do something like that, if I design a let's do. I'm just gonna put a 2D polyline down here. And I could go to my 2D to 3D by surface model. So it would set it on that surface. I'm going to put that on either pad or merged, either one. Let's put it on merged, doesn't matter which, it's the same right in there. Here's the polyline. I'm going to drop that. No, that's why, let's just put it right straight on it. And I'll say, okay. And so now I've put this on the same. I just give you a little context there. You can see that it's now along that bottom, right at the same spot. Now, so what I want to do, this is now a 3D polyline, has a different slope. But if I want to say, keep it right on the ground up here, but I want it to be a foot lower down here. So it's going to be a little steeper than that original ground. So I'm going to say, I want to drop this point elevation. And I can do that any number of ways. I can just modify that, or I could, set a slope. Let's just modify this as I've got a point here at that elevation. I go to this next vertex, number 2, and that elevation here, instead of 1312.63, let's make that 1311 and a half. All right, so I've now changed that. It's now sticking down below that surface at this point, at which, say, maybe I connect to a pipe and I go out to the side, that sort of thing. And just like we did design pad for this up here, let's say I want to make this into a ditch. Well, let's make this a 2-foot wide ditch across the bottom, and it goes up the side slopes at just 1-to-1. So if I go back to surface and say design pad template again, and this time instead of a closed pad, see, it says slope direction from closed pad up here. It's not going to be a closed pad, so it's going to ask me for the direction. So that's where I'm going to set that up. But first I'm going to cancel that. I'm going to first, copy this over 2 feet away so I get the bottom that I want. So I can offset that. It has to be a 3D offset. So I'll go to edit 3D polylines, offset 3D polylines by interval. I'll say okay, and I'm going to go a horizontal amount. Let's just go 1 foot and a vertical amount of 0. I'm going to go from here to here, and I'm going to go from here to here. And I can even at that point, I've got the 2 ends. I could even get rid of this one now. I don't need it anymore. So I have that. Now, here's where the design pad comes in. If I go back to surface, design pad template, and I'm going to call this C pad dash ditch just to put it on a different layer. I'm going to pick this polyline, and because it's not closed, I'm going to put that up into my merged or pad, either one. And I'll go this time 1-to-1. It asked me to show it which side. So I'm going to go to that side. And the pad bottom, thought I had changed that to 1311.5. Oh, I'm sorry. Escape all that. And then what I forgot to do is I'm going to go to design pad template, but I'm going to uncheck this slope pad design. That's why it asked me for that. So now I'm going to say, okay, I'm going to take this polyline. I'm going to put it on into this merged surface 1-to-1. And I'll pick that side. No, and no. I'll repeat the process. Just keep the same thing, go this side to this surface, 1-to-1 on this side. No and no. Now, what I've done is I've got this structure that looks like this. So it's right on the ground up here, and it goes down and it gets gradually a foot deep down here, okay? Makes a ditch. But, you know, I've got a little gap in here, so I'm gonna need to do a shrink wrap and make a little separate surface. So I'm going to go to view, isolate my layers. I'm just going to do a crossing to get all of those layers. And now I'm going to do a draw shrink wrap boundary. Cross a gap, I'll put it on that layer called boundary. I'll grab all of those items. There now is my boundary. I'm going to go to surface, triangulate and contour. I'm going to change the file name to ditch. Use inclusion, exclusion. I'll say, okay, I'm going to grab that boundary. No more, no exclusions, and then grab my data. And I look at that surface, my ditch. And you can see it there with the contours in it, okay? And now I can just, I'm gonna erase that one, just get out of the way. And now, just like we did before, under triangulation file utilities, I can load the base file, which is merged. I'm going to choose next, color that in just to see it. And I'm going to merge that file. This time I'll turn on the colors just so you can see them. And I'm going to put ditch into that. And I'm going to save as, and I'll call it merged again. Yes, I can overwrite it. It's saved. I'll exit my work. I'll go back to my restore layers. And then I can look at this, all of this information here in my viewer. I can verify my surface was also including that ditch. Now, again, you'd have to handle something down here if you're using that for drainage. Okay, if I load the surface first, merged, and look at my contours now, you see how these contours are exactly where they're supposed to be. They come across, they hit they have to climb up out of the ditch. Okay, so, and it's shallower and shallower as I get up to the top. So, in fact, if I look at that at, say, you know, half a foot, you can see more of them, how they get smaller and smaller as they come across. Okay, so that's the whole process of grading design. You build it in pieces and you merge it into those files. Now, in terms of doing contouring, you could contour this whole surface and you could use this as an exclusion so that it doesn't contour in the middle. And then you could maybe contour the pad design and only use, that as a limiting factor. And you would then turn, use them to only draw within that area, maybe on a different set of layers. And that's how you would wind up with something that would look like something like this. You draw your contours with different layers, different colors, like maybe right in here. You see where I've got my existing contours, but I've trimmed them with that line, but I didn't actually delete the contours. I just contoured up to that exclusion boundary. So that part's in your layer. Okay. Now, I'm sorry, I see that Bill had to go too. I got one little quick thing I wanted to show you here that can be very helpful for you. And it's a different module, actually two different modules. And you're not going to have these, so just sit back and watch. If I switch to my GIS module, now you may have it if you bought the Civil Suite, I think that's included. So I'm going to get a different set of tools here. And I'm going to look under the images and I'm going to place a Google Earth image. And it wants to know an output file. I'm just going to call it site. I'll say save. I'll choose my corners from the screen and I'm going to go from here up to here. And I can choose the different resolutions that might be available. I can get different types, a road map, I'm going to use an aerial map, set it in the background and layer imagery. I'll say okay. And it's going to go out to Google Earth and it's going to find this and place it in my drawing. Then I'm going to come here and change this fade. Just to tone it down a little bit so we can work with it. But see how it sort of misses. It doesn't really hit things correctly, right? Well, that's the nature of Google Earth. It's not very accurate. It's close enough, but it's not survey type accurate. So what do I do with that? Well, if I were to try to simply move that image and move it from this corner to this corner, well, it might fit in this corner, but then over here where this corner misses, it's still going to miss because this is warped a little bit. There's some rubber sheeting that's been going on as part of that process. So if I switch to this module, and this is one you probably don't have, it's called CADNet. It's just one of the additional Carlson modules. That now gives me a raster menu where I can do this thing called rubber sheet. I got two different methodologies. The inverse distance is going to give me my best results in this particular type of transformation. And I'm going to say, okay, now it's going to ask me to pick the origin of the first control point. So I'm going to go into the picture and I'm going to find something in the picture that doesn't match. You see these inlets. Well, I'm going to go from, I'll turn that snap to none. So I can just grab there and then I'm going to put that in the midpoint there. I'm going to do another one right here from here to the midpoint. And maybe I'll do one more down here. Say from, I'm going to choose none temporarily. That midpoint. All right, so that tightened that up. I'm going to look for some corners that I can use. For instance, back in here's one. So I'm going to go from right there and I'm going to put it right there. Same thing here. I'll go from right in there, looks to be, to there. Let's see, a couple of other corners that I might be able to use. Let me get something up in here. So if I go from, say, here on the outside of that edge, and I'll go to right there. Maybe one in here, I'll go from this, the last part of this straight part right here down to there. Okay, so I'm just going around finding things that I might use. That's almost too high, but I'm going to find these. Here's a good one. There's a corner of the photograph needs to go to there. I've got one right here where the corner of that photograph needs to be right here. So all of these little movements are different and different sizes, but they're going to help me to warp that image into position. So that's probably enough you can get a sense of how this is going to work. When you're done, you hit enter, and it's going to take all of that information and it's going to warp the pixels of that image and move it into place. And you see how I jump? Now my inlet matches there. Look how well my curve matches now. I come up here to the top and I say, hey, my curve looks pretty good in there. Over here to those original inlets, you can see they were way over here, I think. Yeah, there you go. You see how those inlets are now lining up. So now everything lines up. So if I miss something in my survey, or if I need to go out here, I can actually just draw this around here and be confident that it's really accurate as opposed to what the Google Earth image was. Okay. See how my curves are all matching now? My islands match. We don't have all that offset. All right. So that's something you might want to consider when you start to use this a little more often. You can add those two tools. It's the GIS module that lets you bring the Google Earth image in, or you can bring the Google Earth image in manually, another way if you'd like. Get it placed nearby close enough, and then go to that CADNet module and go to raster and choose rubber sheet and bring those in. Okay. And with that, I can let everybody go and have a weekend. If you got any questions, let me know. But again, just get in here and work with it. Use these exercises to help reinforce, what we've gone over. And hopefully that gives you a little bit of grounding in what you're doing and the processes that you would normally use, how to grade stuff, how to create a pad, how to create a ditch, how to create a parking lot, those 3D offsets, laying things down on surfaces, that sort of stuff. Okay.
I appreciate your wisdom, Ken.
Well, it's hard earned. Like I said, I've been doing it for 40 years, so you're not going to necessarily see.
Oh yeah, it ain't easy.
So,
But this definitely has been a good start for me. Like I said, I'm really green into it, but I mean, from what you showed me, it at least lets me know where all the tools are.
yep. Yeah, I think that gives you an idea, and the fact that there's many ways to do the same thing. You can change properties, you can do a Carlson command on it, you can simply draw something. Anything that you can use that does the same effect, they're all legal. Nothing's right or wrong as long as it does what you're trying to do. Okay?
Right. Definitely.
All righty. Well, with that, now I'm going to send everybody out a link that lets you go to YouTube and to my Carlson page and get these Tuesday sessions for your further review at any time. You'll also get your certificates of completion. There'll be a couple of days before I get all that processed and delivered, but that'll be something you can rely on. You've got my email. You can send me questions if you have. questions about stuff, and we'll just go from there. And hopefully you'll, grow with this as you use it. I hope that you find that it's a very powerful set of tools, and a lot of people who have used Carlson for years aren't, they've never been aware of all of the different power that it really has. And it's really quite a sophisticated piece of software. So
Absolutely.
so good luck with it. Have fun. I wish you guys a great weekend. Let me
You
go
as well.
stop the recording. Thank you.